Hello and good morning. And I'm Dan Galpin. And according to a recent Google search that I did, it turns out that there are lots of things that people are scared of. Things like airplanes and flying and snakes and spiders and going to the dentist and public speaking and even the number 13 for those triskaidekaphobics out there. But a new release of Android is nothing to fear, and even if it is the 13th release. So I'm going to cover two things in this talk. The basic process for dealing with migrating to a new Android platform release, along with how this applies to Android 13 specifically in terms of the changes it brings and how they might apply to your app, and how to dig deeper into this content with other ADS talks. Remember, there are three kinds of people: those who can count and those who cannot. When migrating to a new Android release, I look for behavior changes and new features that I can potentially utilize to differentiate my app. And a behavior change really is a big deal because it means that this app that worked fine on earlier releases of Android may not work exactly the way that you expect them to on this new release. So for that reason, we really try to limit these kinds of changes to things that impact system health and a focus on battery life and system performance, things like user privacy and the security of the OS and your app. Now, some of these changes apply to all apps, and some of them only apply once your target SDK version actually targets Android 13's API level 33. So, the first line of defense is to test your app thoroughly on the new release, and this just means, Android 13. And it's available in many places, such as the Android emulator, the supported Pixel devices, partner devices, and things like the Firebase Test Lab. And the behavior changes page on developer.android.com is a guide for what to focus on, and I'll be covering some of the more notable changes in this talk. Beginning with changes that impact all apps regardless of their target SDK version. And the overall goal of these changes is to give the user more awareness and control of what apps are doing in the background. Now, users told us that they really, really wanted foreground service notifications to be dismissible, so we added that. To then provide more clarity around what apps are doing in the background, we created the Foreground Services Task Manager. And if your app is using a foreground service, it gets included in this new interface that allows the user to end the foreground service, which also closes your app. You can use ADB for testing to stop your app exactly the way the FGS Task Manager does using this stop app command. And in many ways, this is really similar to the force stop command, which you can do from the app info page or from the force stop ADB shell interface. Unlike force stop, though, it doesn't actually remove the app from history, and it doesn't cancel scheduled jobs and alarms, so this should actually be easier and have less of a long-term impact on your app. Now, when your app is stopped in the FGS Task Manager, you won't get any callbacks from the system, but you can check what happens the next time your app starts using the Application Exit Info API. And this will tell you if the user stopped your app and allows you to check for things like crashes and ANRs, unhandled exceptions, and low memory. And there are two takeaways from this for me. First, as always, make sure your app can handle being stopped at any state, minimizing data loss. Second, this is a really good time to do some analysis and see if you really need to rely on foreground services. Because foreground services really reduce the flexibility for Android to be able to schedule things. And using jobs is just better for the system health. And speaking of background activity, on Android 13, your app requires a much shorter period of inactivity to be replaced in the restricted app standby bucket. We added these in Android 12, and when you're in restricted mode, you can run jobs once per day in a 10-minute batched session, which must be run with at least one other job. You can run fewer expedited jobs, and you can invoke one alarm per day. So if your app detects that it's in restricted mode, you can help make sure your app schedules any necessary operations appropriately, and it's at least worth logging what state your app is in when you're running jobs and alarms, so you can help track down any unanticipated behavior. Now, you can use ADB to test your app standby bucket if you want to run some long-term tests, but note that your app can't actually be running, because if you try to actually execute this while your app is running, the app will actually say, hey, I'm being interacted with, and it'll automatically kick itself out of this restricted bucket. Now, one of the ways to get users to interact with your app and keep it out of those restricted buckets is to get users to, send them relevant, actionable notifications that they interact with. But Android 13 now requires you to hold a permission in order to do that. And Android asks for this permission on your behalf if you haven't yet targeted SDK 33. And it does this as soon as your app has an active activity and has created a notification channel. And this is different than every other time we have introduced a runtime permission. Now, if the user disallows this permission, they won't be prompted again unless they uninstall and reinstall your app, or you upgrade your app to target SDK 33. Now, if your app does target SDK 33 or higher, you get to manually ask the user for the notifications permission. And so you have complete control over when the permission dialog is displayed. You can call our notifications enabled, which is an Android X function, to confirm whether notifications are actually enabled for your app, and notifications related to media sessions are exempt from this behavior change. But in general, the foreground service notifications are not. You can use ADB to revoke permission flags and permissions and clear permission flags for testing. And be sure to catch Terrence and Nake's talk coming up for best practices on requesting permissions, including the new notification permission. So we also have behavior changes that are related to privacy and security, as I stated before. And we've locked down intent filters to behave more like I always thought they did. So on Android 13, when your app sends an explicit intent to an exported component of another app that targets SDK 33 or higher, the intent is delivered only if it actually matches the intent filter element in the receiving app. And so if your app has been relying on this legacy behavior, you'll have to fix things. If your app has a centralized handler for exported as well as non-exported intents, adding a little bit of code to your receiver to filter out disallowed actions can prevent an external app from unexpectedly triggering internal code. And this is something you should do as soon as possible, even if you aren't ready to target SDK 33. We've removed the compatibility trampoline for the speech service from the Google Search app in Android 13, so use the device's default provider. Basically, this means don't specify a component name in the recognizer intent. Android 13 now has a handy pop-up that provides a visual confirmation of clipboard contents. So we've added a way to prevent sensitive data, such as passwords or credit card information, from getting shown if copied to the clipboard. And this is also something worth doing as soon as possible, regardless of what SDK version you target. Android 13's SDK does give you a string constant. You can just use this one. Finally, if you're relying on shared user IDs, which is a really cool feature, but it has problems with package managers, so please migrate to supported communications mechanisms. And since removing the shared user ID from your manifest also prevents your app from ever getting updated, we've added this way to migrate, so it's only not used on new installs. And that's really most of what you need to know about behavior changes for apps that are not targeting SDK 33. But if notifications are actually important to your app and what it does, you probably want to target SDK 33 as soon as possible. Then you can request permission in context, with justification. And so you'll also have to do this by November of 2023 in order to continue making app updates on Google Play. So you might as well just get started now. So what behavior changes also happen when you target SDK 33. And this is typically where we put more substantial changes, since targeting the SDK version implies that your app has actually been tested against that version. So let's start with privacy and security related changes. And here's actually a nice one. So on earlier versions of Android, the user needs to grant your app access to find location for some common Wi-Fi use cases. But on Android 13, we introduced the Nearby Wi-Fi Devices runtime permission in the Nearby Devices group. So if you assert in your manifest that you are not using your Wi-Fi access for location, and your app doesn't use methods from the Wi-Fi manager class such as start scan and get scan results, you can just use the Nearby Wi-Fi Devices permission. However, this means that you'll actually need to request the Nearby Wi-Fi Devices permission once you target SDK 33. Otherwise, accessing many Wi-Fi APIs will cause an exception to be thrown. Next, if your app needs to directly access media files created by other apps, once you target SDK 33, you need to request one or more of the granular permissions, media permissions, instead of the read external storage permission. And it's even better to avoid these. In everything about storage on Android, Yassine is covering key storage concepts, along with recent APIs that go even further to preserve user privacy. Targeting SDK 33 also means that you have to request the new body sensors background permission in existing to the body sensors one to actually get access to these body sensors in the background. But it's also a hard restricted permission that the package installer has to allow list. So you should probably just use Health Connect if you need to consume health and fitness data. So Garen has a whole session on this. With each new Android release, we are trying to eliminate the calling of non-SDK interfaces. And when it makes sense, we're trying to replace these hidden APIs with public alternatives. As you can see, there are only 4 in Android 13, so I can put them all on a slide. We have system health behavior changes that only occur when targeting SDK 33 as well. So once you target SDK 33, if your app gets in the restricted state, the system doesn't deliver the boot completed broadcast or the locked boot completed broadcast until your app has been started for other reasons. And to make it easier for you to test behavior changes, we have this thing called the compatibility framework, and it allows you to toggle on and off specific behavior changes for your app without even changing your app's target SDK version using either settings or ADB. So you can test this particular one, for example, by setting the defer boot completed broadcast change ID option. And note that your app will never get into the restricted state if the user adds your app widget. So definitely make sure to see what Marcel has to say about modernizing your app widgets. The rest of the behavior changes in Android 13 are more about improving the user experience. So when targeting SDK 33, media controls are now derived semantically from the playback state that's linked to your media session, if available, rather than displaying up to 5 controls from media style in the order they were added. And this not only provides for richer media controls, it also aligns how they're rendered across phones, tablets, Android Auto, and Android TV. For more on how to create a great media experience that works well across various device hardware and platform versions, check out Nevin's talk. When targeting SDK 33, the set force dark method in WebView is ignored. WebView now always sets the media query prefers color scheme according to the app's in-light theme attribute. And you can still customize your color theme behavior using the set algorithmic darkening allowed method in Android X. Finally, apps that target SDK 33 or higher that use advertising IDs need to request the ad ID permission in the manifest. So if you're using an advertising SDK that targets this, targets SDK 33, it'll hopefully do this automatically in your library's manifest. And this brings up one of the key things you should look for when targeting a new Android SDK release, which is the target SDK version of any SDKs or libraries you might be using. And this is particularly important if you're using pre-compiled libraries that target earlier SDKs, because this can cause failures. They haven't been modified to account for any recent behavior changes. And without source code, Android Studio isn't going to warn you of any potential problems. Now you can use the Google Play SDK index to see what the target SDK level is for many commercial SDKs. So now, after all that, you're targeting Android 13 successfully. Not much there really, but what's next? Consider getting rid of your storage permissions entirely and switching to the new Photo Picker API. And this allows the user just to share specific photos and videos with your app. And it's a rich photo experience. It's supported back to Android 11 using an SDK extension, which is a technology that uses Google system updates with modular system components to add functionality to an OS release. And this helps us also to ensure a consistent experience across devices. Now, if the photo picker isn't available, it falls back to using Action Open Document. And this works back to SDK 19, and it has a less rich experience, but it's still pretty nice, as you can see. So using Photo Picker involves first registering for an activity result callback, and this selects whether you want to allow single or multiple pieces of media. And then you launch the Photo Picker with the type of media you want the user to select, images or videos, or both. And then you can call is Photo Picker available to check for the presence of the full Photo Picker experience if you want to provide something alternate. Internally, is Photo Picker available calls get extension version. And this is actually how you check for the presence of an SDK extension at runtime. So this is the future. And if you're no longer using a runtime permission like read external storage on Android 13, your app can revoke it using the revoke self permission on kill. And this is pretty cool. It's just a no-op if your app doesn't already hold the permission. And if it does, the system will kill your process opportunistically. And the next time your app is launched, the permission will no longer be held. Speaking of privacy, Aaron is covering the latest updates to Privacy Sandbox, a project that looks to enable effective, personalized advertising while improving user privacy. And this includes an overview of the project and how ad tech providers, advertisers, publishers, and app developers can utilize it. Android 13 includes new graphics capabilities, including programmable shader effects and front buffer rendering for low latency stylus support, and Samir and Chet dive into this deeply into their Android graphics talk. Android 13 includes new communication capabilities, such as MIDI 2.0, BLE audio, ultra-wideband, along with new media capabilities, such as HDR video recording, anticipatory audio routing, and spatial audio. And Luke covers what new capabilities BLE Audio brings to the platform, as well as how to make use of it in your VoIP applications with the Telecom API. Carlos gives an introduction to ultra-wideband, a radio technology that can provide secure and accurate proximity data around nearby devices, enabling digital car keys, new home control possibilities, and more. Ray covers how you can capture, playback, and share HDR video, showing you how to test for its availability in capture and playback, as well as how to transcode your video to SDR as needed for sharing. Android 13 also includes a bunch of new text features, including Unicode updates and support for color vector fonts in the COLR v1 format. In addition to improved text support for internationalization, Android 13 now supports per-app language preferences. Whether your app already has support for per-app languages with an in-app language picker, or whether you want to add support for the feature, the AppCompat APIs in Android X make it easy to support Android 13 while being backwards compatible back to Android 4.0. For more on making your app work better for more users, including more on per-app language preferences, check out Ash's talk on building for a multilingual world. Speaking of making your app work for more users, Karen's talk on how we built accessibility support for Jetpack Compose covers the 3 most common accessibility services, how Android integrates with them, and how this informed the design of accessibility in Compose, along with tooling and best practices. Support for the new tile placement API helps users customize their Android experience, allowing apps to provide custom quick settings tiles to prompt users to add the tile in one step without leaving the app. Android 13 also includes all of the enhancements for tablets and foldables that are in Android 12L. And this just gives users better support for their favorite form factors. Rebecca covers how you can go edge to edge with your app on all form factors, take advantage of dynamic colors and Android 13's themed app icons, and get your app ready for the future with support for predictive back gestures. So in conclusion, there are 2 things that I would like to leave you with. First, many of you will be able to migrate and target SDK 33 with minimal changes. So start testing your apps if you haven't already, because there is a lot of benefit to targeting Android 13 and a bunch of cool stuff to take advantage of. And third, we've got so many in-depth talks coming up shortly here at the Android Dev Summit Platform Day, including how to make sure your app is ready for 64-bit devices like Pixel 7, the latest in hardware-accelerated machine learning, how to leverage attestation to improve the security of your app ecosystem, how to leverage the latest Google Play commerce features, and the hashtag AskAndroid session, where the Android platform experts take your questions. And, sometimes those scary things can be cute and fuzzy when you examine them a bit closer. Sometimes, at least. So, thank you.
Thank you. Hello, hello. My name is Rebecca, and I lead the System UI team in Android Developer Relations Engineering. So, users expect their apps to just work. But if you think a premium experience is still a nice to have, then I'm here to say that these days, it's what users expect. They want their apps to be modern and elegant, personal and accessible. So let's talk about how the Android platform can take you there. With 3 recent features that can help your app straight out of the box. First, edge to edge. Achieve a premium layout, an immersive experience, and scale to foldables and tablets. Second, predictive back. Gesture navigation is gaining traction year on year, so in Android 13, we've released some major improvements to the back gesture. It's predictive, informative, and delightful. Third, dynamic color. Designing an accessible color system is essential for any modern app, but you don't need to start from scratch. We've got you covered. So let's get into it. building a premium layout with edge-to-edge. So making the navigation bar transparent has been a key piece of feedback from our Android users. In fact, this was the case in Android 13 and in 12 and 11. So from Android 11, the recommendation has been to draw behind the status and navigation bar. And we call this going edge to edge. To avoid overlaps with the system UI, you can use the system bar and system gesture insets provided by the platform Window Insets, or using Window Insets Compat from Android X. Window Insets have been around for a while, with a revamp of the API in Android 10 and 11. So here's an example of how Google Slides is applied edge-to-edge, giving that full immersive experience that users love. Note how on scrolling, the contents draws under both bars, and how that floating action button stays fixed as you scroll. For Gmail, the design means that they don't draw under the bottom navigation bar, but they can still ensure that the nav bar color matches, so no more black bars. Great. So how can you implement this? There are two places to make this change. First, in your theme, set the status and navigation bars to be transparent. And yes, you do need to do this for both Compose and Views-based apps. Second, in your activity, call set decor fit system windows to false on window compat. Before Android 13, apps needed to use the System UI Visibility API to set a whole bunch of flags to be requested to be laid out full screen. These APIs were deprecated and replaced with this one call. This single argument in set decor fit system window controls whether or not your layout will fit inside the system windows if true, or draw behind them if false. And to keep the fab pinned as you scroll, using Jetpack Compose with the updated scaffold in Material 3, the insets padding is automatically handled for the fab, so no direct insets code is required, unless you want to customize it further using the modifier. This is really nice, as for views-based content, you would need to call windowInsets.getInsets for the system and navigation bars and handle that padding yourself. And so, with these changes, your apps can reap the rewards, not only on mobile, but for foldables and tablets too. Second, create a delightful navigation with predictive back. Gesture navigation is a fast, natural, and ergonomic interaction model. And while the back gesture is the single most popular, we see that some result in people leaving the apps by mistake. And we call this falsing. Users tell us that as they navigate the app, they like to have visual clues to indicate where that gesture is going to take them, especially if that is outside of the app. So it's quite possible that falsing has been affecting your end metrics. So in Android 13, we released predictive back to help apps feel more elegant and informative, and to lend a cohesive feel across all apps. See here on the right, as that user swipes back, they see that sneak peek of the home screen to let them know that they're about to leave. And to support this predictive animation, System Back has moved to an ahead-of-time model. So starting in Android 13, apps need to tell the system in advance if they'll be handling back events. So before the back gesture starts, the system knows whether an application is handling system back, or if it should take control and display feed-forward hints. So in this back to home example, the system knows ahead of time whether the next back gesture will be popping the in-app backstack, or if it will be returning to the launcher, allowing the system to preview the app dismiss and revealing the launcher behind. The cornerstone for predictive back is a new platform API called onBackInvoked callback. And this interface has one main method, onBackInvoked. And so this will be called instead of the legacy onBackPress methods. To register one of these callbacks, you need to call onBackInvoked dispatcher from an activity or a dialog. And once you have an instance of the dispatcher, you can register a callback. And we've already updated the Android X library with the on-back press callback starting in 1.6. And under the hood, it is still calling those same platform APIs. It's all taken care of. So for Android 13, you can opt in by setting Enable On-Back Invoked to True in your manifest. And if you don't have any custom back navigation in your app, then that's all you need to do. If you do, then before you target Android 13, you can test if your app works by setting this same flag. And then once that flag is set, key callback and on-back pressed will no longer be called. So let's take a look at an example. So once you upgrade to Android X 1.6 using Jetpack Compose, you can see here in this simple button example that the navigation component and the usages of Backhandler become instantly compatible with Android 13, while still being backward compatible with previous versions. Use the recommended Android X activity library and its on-back press dispatcher API to register and unregister callbacks. This is all thanks to the ahead-of-time model that Android X library had in its on-back press dispatcher API. Now let's test. Go to Settings, System, Developer Options, Enable Predictive Back Animations, then launch your app to test the back gesture. And coming in Android 14, users will get a similar experience when they swipe within the app, letting users know where back is going to take them by leveraging default or custom animations. And third, create an accessible color system with dynamic color. So how does your app express your brand? How does it look in different light settings? And does it allow for the user's preference all at the same time? Users like their apps to be accessible and expressive. Developers want their color system to be scalable because handling many color systems is getting harder and harder to manage. That's why in Android 12, we released Dynamic Color, the modern color system. Dynamic Color and Material U allow for personalization across the entirety of a user's device and allows for apps to align with their user. So here's how it works. Custom palettes are generated from an individual's wallpaper. And in Android 13, we released color variants, allowing for even more palettes. So let's take a look at some of the underlying principles of dynamic color. Making it accessible. That's the only way to design for everyone, ensuring that the products that you make are inclusive to the widest possible audience. So in this example, two different hues are seen here, orange and green. But when they're grayscaled, we find that there's very little contrast between them. So you can improve this contrast ratio when grayscaled by updating the chroma and the tone, but still honoring the hues. And this is a core principle in the creation of every dynamic color palette for any given wallpaper. Making it scalable. Design tokens enable flexibility and consistency across a product by allowing engineers to assign an element's color role in a UI rather than a set value. And this creates a unified color system and increases that ease of collaboration between designers and engineers as they align on the same color tokens. So let's take a look at some code. So using Compose, create your default light and dark color scheme and leverage those dynamic color tokens. As you can see, there are many and many more than I've listed here. So when creating your theme, you can also add custom color tokens you need, like brand colors, or maybe you have protected colors with semantic importance. So for example, in a caller app, you may always want that hang up button to stay red, but you don't mind so much if the chroma or the tone shifts. And then create your app theme. Note that the dynamic color logic here is gated for Android 12. And so what's the result? Meet your users where they are, with dynamic color available across many of our device partners. And the app isn't the only opportunity to connect with your users. The home screen is too. Leverage app widgets and your adaptive icon. And you can check out Marcel's talk later on app widgets. But finally, let's take a look at that one-line code change you'll need for themed up icons in Android 13. So, 2 steps. 1, import your SVG icon as a vector drawable. And 2, add the monochrome tag pointing to that new vector drawable. And that's it. So for more information, check out that Google link here. So to summarize, designing premium apps can sometimes sound daunting and arbitrary, but with edge-to-edge, predictive back, and dynamic color, you have these features that can help you right out of the box to make your apps modern and elegant, and to keep your users happy. Thank you.
Hey all, I'm Ash Noe. Let's talk about building for a multilingual world. Much of the world is multilingual. A quarter of India and 2/3 of the working adult population in Europe is multilingual. The multilingual population in the United States has increased nearly 200% over the last 40 years. Developing English first or English only could limit your app's reach and helpfulness because 90% of Android devices are shipped outside of the United States and other native English-speaking countries. And consumers prefer to consume content in their own language and might not make a purchase unless they can access information in their own language. The goal of this talk is to provide you best practices to internationalize and localize your app to improve your app's helpfulness and reach. Our first tip is to organize your app resources so users receive information they understand. And the key point here is to be mindful of scripts. Basics first: language, script, and region. Language is what we use to communicate and be understood by others. Script is our writing system, and region is a place. For example, a user may speak Mandarin, which is one of the Chinese languages, write in traditional or simplified Chinese, and live in Taiwan or China. As app developers, we organize our app resources by language, script, and region. So, for example, we could place our string resources in values folders that are appended with language tag qualifiers. We can place our simplified Chinese strings in a values-ZH folder, ZH for Chinese. And we can serve content to users living in Taiwan in a values-ZH-RTW folder, R for region and TW for Taiwan. In Android 7, we added support for scripts. So we might place our fallback string resources in a ZH Han T folder. Han T here stands for the traditional Chinese scripts. Android does its best to serve the best available resources to your users. So for example, if Android cannot find the correct string resource for a user living in Taiwan in the appropriate folder, it will fall back to a more generic folder, in this case, the Han T folder. And then ultimately, it will fall back to your app's default locale. However, Android will not fall back to the ZH folder because the ZH folder contains simplified Chinese strings, and simplified Chinese and traditional Chinese are different scripts. In other words, when organizing your app resources, be mindful that resources do not fall back across scripts. Our second tip is to define resource configurations so your layouts are consistent. Imagine your user has set their device language preferences to be Japanese first and then English. And our application supports English but does not support Japanese. And yet, the user could see this state where the text is in English and the dates are in Japanese. How is this possible if our app does not support Japanese? This initially terrifying but helpful screen can show us why. We can get to this screen by going to Build, Analyze APK, select our APK, then select Resources, select string, and then we'll notice there are a number of string configurations, a number of string resources across 89 configurations. These configurations are language tags. In other words, Android thinks that our app supports 89 locales, which makes no sense to us because our app only supports 4 locales. What's happening is that Android is pulling string resources from our app's dependencies, and our app's dependencies might support 89 locales, including Japanese. So Android will start doing things like internationalizing the dates and times to Japanese, because that was users' first device language preference. We can avoid this by defining a resource configurations in our Gradle file, which is simply passing a list of our app's supported languages. Then Android will know which locales our app supports, our APK size will shrink, and users are not going to see that inconsistent layout. Tips 3 and 4 are to avoid concatenating and reusing short strings. The problem with concatenating in code is that it makes it almost impossible for human translators to rearrange the string sentence structure when localizing to a different language. So for example, in English, we might make an assumption and place the adjective before a noun separated by a space. A translator translating to another language like Spanish would have trouble with this because the noun usually comes before the adjective. And translating to Japanese might be tricky because words aren't separated by spaces there. So don't concatenate. Portuguese speakers, can you spot what's off? The word off here is translated as if Bluetooth were feminine, but Bluetooth is masculine. This can happen if we reuse the short string off throughout our UI, because the short string off by itself does not carry any context as to what it's referring to, whether that be internet or Bluetooth. So instead of concatenating or reusing short strings, consider providing more independent string resources for every language that your app supports, and better yet, if those string resources contain context with them and comment strings, that will help out your translators. Our 5th tip is to use message format for flexible string formatting across languages. And for this section, we're going to consider the library in the context of string plurals. Imagine for this section we have a single goal, and that's to urgently inform the user there is a single day left to do something important. Otherwise, we'll just let them know how many more days left they have to complete a task. This is easy to do in English, but more difficult in other languages because there are different forms of cardinal numbers across languages. In English, there are 2 forms, one and other. One maps to the quantity 1. Other maps to all the other quantities, 2, 3, and 4. So we could have a single string resource last day for the quantity 1, and we could have a string n days left for all the other quantities. So our goal is met in English. However, it's more difficult in other languages. For example, in Russian, there are 4 cardinal forms, one, few, many, and other. And 1 here maps to the quantity 1 and to the quantities 21, 31, and 41. So if we applied what we did in English to Russian, the user would get this last day message when there's 21 days left. And this is where message format is helpful because it has this =1 syntax that is unique to message format and doesn't exist in other ways of handling plurals within Android. =1 can be used to reserve a string resource when there is a single quantity left of something. In this case, it's the last day. The message format syntax is different. Briefly, days left is a variable that we'll call later in our Kotlin code. Plural is a keyword that's letting the library know we're working with plural strings. =1, one, few, many are keywords that are mapping our quantities to the string. Our strings go in curly braces, and the # here is a placeholder for the quantity. In our code, we'll pass the string resource into the message format API. and then we'll format the string by mapping the quantity 1 to the variable days left. Then the user in their UI would see that last day message, and that will work for all languages. It's important to call message format from Android ICU because there's multiple message format libraries within Android, and the one from ICU has the best internationalization capabilities. Message format is really robust. It can be used for flexible string formatting across languages. Consider it for ordinal numbers, dates, times, gender, and nesting complex message strings. After you've localized and internationalized your app using those tips, you can take advantage of a new feature called per app language preferences. Before we talk about what this feature is, we'll talk about why it's important by exploring 2 user journeys. Our first user journey. Imagine you are a Latina woman who lives in the United States. You lead a sales team and primarily use LinkedIn in Spanish to find and stay connected with your clients. However, you prefer to navigate through your phone in English. As another user journey, imagine you are traveling to the Netherlands and you need Google Maps in Dutch so that streets and businesses are pronounced correctly. You live in the United Kingdom and prefer your device in English. This feature allows multilingual users to set their app language to be independent of the system language. As a developer, you can provide this functionality to your users in 2 ways. First, in device settings, which is available in Android 13 and above. The benefit here is it is a centralized and discoverable location and super easy to implement. You can also create an in-app language picker, which can be backwards compatible. If you do both of these things, they sync for free. Let's talk about in-device settings first. On the right, you see a video of a user navigating through the Settings app to the App Languages page that shows a list of apps that support this feature. The user can then select an app and see that app's supported languages, like you can see here with LinkedIn. LinkedIn is planning to offer this feature in the upcoming weeks, and we're so happy that they considered this an easy integration with minimal code changes. Let's explore the in-app language picker next. There are 2 approaches to creating an in-app language picker. The first approach, which LinkedIn has done here, is to just delegate out to the Settings app. So for example, in your LinkedIn app, you'll be able to go to your settings, press account preferences, under general preferences, select language, change your app language, at which point you'll be redirected to the Settings app to change the LinkedIn app language. Another approach is to use our backwards compatible runtime APIs, like Google Maps has done here. The Google Maps in-app language picker was existing, but they migrated their backend code to call our runtime APIs, specifically so that their in-app language picker could sync with the device settings. So no matter where Google Map users change their map app language, whether that be in the Settings app or whether that be within Maps itself, Maps appears in the correct language to the user. You can learn more about how to implement per app language preferences by consulting our developer documentation or our YouTube video. All right, I hope that we have convinced you why it is important to internationalize and localize your Android application to improve your app's helpfulness and reach. Here's the checklist again, and thank you so much for watching.
Hi, my name is Mozart Lewis, and I'm a developer relations engineer advocating for Android Camera. Today, we're going to talk about improving your social experience quality with Android Camera. Now, most of this talk assumes that you use the Android Camera 2 framework and within your app, and you know concepts like the camera manager and the camera device, as this isn't a getting started guide. And features here will also be available in Camera X sometime in the future. So let's get started. Camera is at the forefront of social. Camera is such an important part of the mobile device, and users are always interacting with the camera, especially in the context of social. In fact, we have over 60% of images and videos are taken from apps other than the native camera app. So you can think of these as like social apps that we know and love today. Users are also spending an average of over 2 hours on social apps daily, and most of the apps contributing to that time have camera at the forefront. Because of this, and because of how important camera is to the ecosystem, Android has doubled down on things that matter most with camera, especially in the context of quality and performance. We want to ensure users are able to take the highest quality photos and videos possible and make every single pixel count. We also want developers to be able to ensure the best performance in apps and make them fast, responsive, and good for everyday social and non-social needs. So we've taken feedback from developers on exactly what they needed from camera, and we've landed major changes in Android 13. Today's agenda, we're going to explore some major updates within the camera ecosystem, covering topics around capture quality and performance. And we'll take a look at how to implement these things into your app today. So let's talk about one of the easiest ways to visually improve the quality of your video, and that's HDR video capture. In Android 13, we introduced high dynamic range video capture, which provides higher contrast and more colors to encoded video. Your camera capture will be able to produce much brighter videos and more saturated colors compared to SDR. Normally, high-end features like this are made available within the user's native camera apps, but what we've done is made this available to any developer that wants to tap into this great feature. With HDR comes 10-bit color capture as well, which enables you to capture a little over 1 billion colors instead of just shy of 17 million. This should make colors in videos smoother and more consistent, and avoid the dreaded banding that can occur when colors are represented incorrectly. So there are a couple steps on getting started and integrating HDR within your app. And the first step is to check for 10-bit dynamics range support. So the first thing we'll do here, the first thing we must do here is use our camera manager class so that we can query some characteristics. The characteristic that we're going to query here is the request available capabilities. This will return a list of capabilities that the camera that is given here is able to do. Now, the capability that we're looking for is this flag here called request available capabilities dynamic range 10-bit. I know it's really long, but that's the actual string there. Now, great. Once you return that, if that's true, we know that your device supports 10-bit. And the next thing we want to do now is try and get a supported HDR profile. There's many available, right? So in doing this, you do the same thing. You take the camera manager and you query a characteristic based off the camera ID. That characteristic in this case is request available dynamic range profiles. This will give you a list of profiles, HDR profiles that are available within the device, of dynamic range profiles available in the device. Now, once you have that, in this case, in this example, we're requesting for the dynamic range profile of HLG10. The reason why we're doing this here, we actually, in this case, don't need to do this because in Android 13, HLG10 is the minimum required profile for capture and playback to provide better consistency across devices within the entire ecosystem. So this means that if you have 10-bit support within your app, then you must have HLG. If the device has 10-bit support, then HLG is definitely supported. But we add this piece here because you may want to support a different HDR profile, like HDR10 or HDR10+. So we have 10-bit support, we have an HDR profile, so let's actually set up an HDR session. Here, we're going to, like normally, we would use and set up an output configuration for every target surface. In here, you'll see that we have a new flag in the configuration. The flag is called config.dynamicRangeProfile. It's here that we can set up our profile that we checked for, that we assured that we have. So in this case, HLG10. From there, what we'll do is configure our session as normally we would, as any camera developer would, and we create a capture session. And this is setting up our HDR capture. So we have our session set up with the dynamic range profile, and now we need to actually encode the video into a file. So here, the first thing we want to do is create our media format instance with a width, a height, and a format. And in this case, we're going to use HEVT, which I'll go into in the meantime. Now, we have a lot of flags that we need to set to do this correctly. Right? In this format .setInteger, we'll call this many times with a lot of these keys. And here they are. You have 4 things to set up to get HDR properly set up. You need the key format, the key profile, the key color transfer, as well as the color standard. So in this case, in this example, our color format would be the format surface. Our key profile will be HEVC profile main 10. Our color transfer will be HLG, and our color standard will be BT 2020. Once again, there is multiple options. You can mix and match depending on what your device supports. Great, so we have HDR fully set up in terms of capturing HDR video within your app. And I encourage everyone to stick around for the next talk around HDR 10-bit video to go from end to end, to capture, to playback, and sharing. Great. So our next topic today we're going to talk about is stream use cases, which can help optimize your camera stream for common scenarios in which you'd use your camera for. So why do we need this? Why is this important? Well, before Android 13, under the hood, the camera didn't really know why you want to use it. So for instance, let's say you wanted to capture an image, and maybe you would want to prioritize image quality. Well, the camera device didn't really know that ahead of time, so there was nothing that the device manufacturer could do to optimize for that particular use case. How does this benefit the developers, though? Well, when you're in session creation time, the camera device will understand what you're wanting to create this instance for. So for instance, now, device manufacturers can optimize for the best performance or the best quality depending on why you're using this camera stream. So you think of an example as if I'm just trying to take a picture, I want the highest quality, every pixel that can count. And so now the manufacturer can say, OK, we're going to optimize for this use case scenario. Whereas if you're doing just, let's say, in-app analysis and just using the viewfinder, you may not need the highest quality, and you can then optimize for performance instead. So here's a list of some of the predefined keys. Right now, we have default, which is covering all existing behavior. We have preview, which is recommended for viewfinder or in-app image analysis, or like AR, augmented reality, things like that. Still capture, and video recording, which is pretty self-explanatory. Video call, which is recommended for long-running camera sessions where power drain can become a concern. You have preview video still. Now, this one is recommended by Google for apps that are trying to use the one stream for everything. So if you're using the one stream to capture images, using the one stream to capture video, and display it to the viewfinder, use preview video still. We also have vendor software, Samsung or any other OEM, to be able to have their own particular predefined cases. All right, so here's a quick demonstration of what it may look like. This is a little dramatized, but if you set a stream, let's say, to preview, if your stream use case is preview, you may notice that there's a jump in frames per second, and it may make the viewfinder feel a lot more real-time and more realistic because this is optimized for performance. This increase in performance, though, may lead to a loss of quality and a less desirable image, and maybe not really great for video. Whereas if you still capture and display that stream on the viewfinder, you'll see that it's like almost the highest resolution photo that the sensor can produce, every single pixel. But the stream is not really expected to maintain preview-like frame rates. So you may see it's becoming very laggy, and it may not be something that you would want to use for the viewfinder. And so you would use this case for just the image capture stream. So So the first thing we want to do to get this implemented is check if your stream use case is supported. Everything must be supported by the device manufacturer in order for you to use it within your app. So we use our camera manager, and we query a camera characteristic. And in this case, we're going to query the scalar available stream use cases. So in this case, we'll go in here. Well, let's say we created this method, and we want to use one of these use cases. We put it into a function like this to check, is this available? So once we've checked that the stream use case we're looking for is available, we want to now set that up during configuration. So it's kind of like the same situation as before. Now we're going to use the example preview video still here. What we'll do is for each output configuration, we have a new flag called config.stream use case, and you will set up that use case to the configuration, and that's pretty much it. You will then continue as normal. And that will help your camera stream for the specific use case that you're using it for be optimized by the device manufacturer. Great. Now, let's talk about one of my favorite acronyms, which is WASAWIG, which is called What You See is What You Get. Now, you may think, what is this and why do we even have this? This is for preview stabilization. So now, if you're familiar with camera APIs, you'll already know that we already have stabilization. So what does this do? If you haven't noticed that there's some cases when you use a multi-stream, where let's say you have one stream directing towards the viewfinder and one stream dedicated to the encoder, what may happen is that what's being seen inside the viewfinder is not equivalent to what gets captured in the encoder. So sometimes that'll result into like a sudden crop into the image, or a sudden there's more there's more in the captured image than what was in the viewfinder, which is unexpected, which is not really good for apps that you want to see what you get. Like you saw what you saw and you didn't get what you wanted to get in that case. So we've implemented preview stabilization, which helps avoid this issue by applying the same exact stabilization that is going to the video encoder to the actual preview, which means that it can crop in, crop out, whatever it may be doing to the encoder as well will be applied to the preview, which will give you the what you see is what you get feeling, which is really important for things like social apps, where they usually will use just one stream in this case. So implementing this is actually really easy. Like everything else, we need to query a characteristic of the camera and see if it supports the control available video stabilization modes. Once you get this list, you will be able to then check if we are able to support control video stabilization mode preview stabilization. Now, once you get this, if this is true, you can set it up in your builder with a capture request, and you'll be able, and then you have preview stabilization happening within your app, just like that. Great. That's the only thing you need. This pretty much this flag and checking it within and setting it within your builder, and you will be up and running with preview stabilization. So the last thing we'll talk about today is camera extensions. Device manufacturers can expose special capabilities like night mode, bokeh, HDR, and third-party developers through camera extensions. Developers can use either the Camera 2 API or the Camera X API to enable camera extensions, which are implemented by the device manufacturer. For this example, you can see how Snapchat used the night extension to brighten up a scene and take a better image under low light conditions on Pixel devices. And you can see how I was able to get a nice bokeh depth of field effect on the Samsung Galaxy S22 that supports extensions. Now, we're excited to say that over 160 devices now support at least 3 or more extensions, and device manufacturers are hard at work implementing and supporting extensions on more and more devices. Here's our list of extensions that are currently available. You have Night, which is useful for low light conditions. HDR, which is good for high dynamic range still capture. Auto, which automatically selects one of these other extensions based off of the environment and what the device manufacturer determines at that time. So you can imagine setting up Auto, and let's say it's really low light conditions, they may then say, okay, we're going to switch to the Night extension under the hood. We also have bokeh depth of field, which is a focused subject with a blurry background, and face retouch. Like everything else in camera, we must query and assure that the camera is able to support an extension. So with a method like this, you can check if a specific extension is enabled based off of the camera ID. So let's see an example of creating a session for the bokeh extension. The first thing we'll do is check if the extension is supported with our previous method. So in this case, we'll get the camera device ID, which may be like the back camera, our camera manager, and let's say in this case, we're looking for the bokeh extension. If this is supported, then we'll be able to continue in this function. Then we'll set up our camera extension session.state callback. This is where you can call the onConfigure and onConfigure failed if everything works well, right? And one of the key differences here is that we don't create a normal session configuration. We create a extension session configuration instead with the extension callback and everything else available there. And when you're calling it on your camera device, what you will use instead is create extension session instead of just create session with your configuration. So let's recap. Today we talked about HDR video, which can improve the color, brightness, and contrast of your videos. The camera stream use cases, which can optimize the camera for specific use cases. Preview stabilization, which assures your users get exactly what they saw in the viewfinder. And camera extensions, which is access to special capabilities from the manufacturer of the device. Now, there's so much more, actually, that we weren't able to necessarily cover today, like concurrent camera, jitter reduction, updates to Camera X. But we encourage you to follow the links here to be able to view all of these extra updates. And the camera team is looking for as much feedback as you can give us for the next version of Android. So we'd love for you to just keep in contact with us and let us know what we're doing that we can improve the platform and camera experience within your app. Thank you.
Hi, I'm Ray Tiong, Developer Relations Engineer for Android Camera. In this talk, we'll walk through how to implement HDR 10-bit video. High Dynamic Range, or HDR, allows for higher contrast and more colors over today's standard dynamic range. Here, we compare two images. Notice that the HDR photo represents more of the tones of the scene and has a sharper contrast. On devices that support HDR, you'll also notice that the sun is noticeably brighter and the shadows are noticeably darker. This is due to the ability to have wider range of nits, or brightness data, per pixel. In this comparison, you'll notice that the 10-bit photo is smoother and more realistic than the 8-bit photo. This is because we have additional bits that we can now use to capture and represent more of the natural colors that actually exist. In SDR, these out-of-range colors are mapped to the closest 8-bit color that is in range. This can, in many cases, create artifacts such as banding, as you see here. HDR allows you to capture media with more color and contrast accuracy due to the fact that more data can be represented. In the remainder of this tech talk, we'll go through how to capture, play back, and share 10-bit HDR video on Android. Let's talk about capture. First, we need to check for HDR support. Note that in-app capture is only available on supported devices, and these devices must be running Android T or later. Here, we check to see if 10-bit range is supported. We also check to see if the profile that we want is available. For instance, we check for HLG. Now, let's set up the capture session. We set the output configuration to the profile that we want. Again, in this example, we set the profile to HLG. If we're using media codec, we'll want to correctly configure the API to avoid any color issues. We'll set the transfer, profile, color, format, and other properties as shown here. Great, Now, let's look at playback. Please note that texture view will only be displayed in 8-bit. Any HDR content you give to texture view will be shown in 8-bit. The quality of the final results will depend on the device's underlying transcoding implementation. For this reason, we recommend that you either migrate to a view that supports 10-bit, such as Surface View or Exoplayer, or if you wish to continue to support texture view, explicitly transcode your 10-bit content to 8-bit SDR. We'll review how to treat your 10-bit content so that it's available for 8-bit use, such as texture view, later in this talk. Also note that Exoplayer supports HDR playback by default. If you are using Surface View, we recommend using Media Codec. Okay, let's get back to coding. First, let's check the device's display capability. Here, we check that the display can support HLG. Then, we'll need to configure the media codec. Here, we set the decoder to HEVC, which supports HLG. And that's it. As mentioned, you may want to share your content, for example, to devices that do not support 10-bit. We'll walk through just how to do that. To ensure you retain the highest quality media in 8-bit, you'll want to transcode them properly. Luckily, Transformer makes this easy. We do this by passing the media through Transformer and enabling SDR tone mapping. The library will take care of the rest for you. Also, stay tuned for HDR support in Camera X, coming in the next alpha releases of the API. There you have it, from capturing playback to sharing. We hope you enjoyed this walkthrough. Give it a try and let us know what you think. Thank you.
Hi everyone, my name is Nate, and I'm an engineer on the Android Permissions team. I'm here with Terrence from the Developer Relations team, and we're going to be walking you through some of the best practices for Android permissions. Over the past several years, Android has continued to focus on privacy. Privacy is a major concern for users, and Android has been continually releasing tools to help users and developers better control how user data is consumed and shared. To enhance user privacy, Android has added the notification permission, to give users more control over the notifications that they see. The coarse and fine location permission split, allowing users to provide apps their approximate location without giving their exact moment-to-moment location. And developer downgradable permissions, which allow apps to revoke permissions that they need only for a short time. To downgrade permissions, call the Revoke Self-Permission on Kill API that's available for apps targeting SDK 33 and above. In this talk, we'll be going over several best practices for using permissions in your app and giving examples of how Google apps apply them. These best practices help users understand why your app needs their permission, and research has shown that users who understand an app's permission requests are significantly more likely to grant that request. Reducing the denial rate by using best practices isn't just user-friendly, it sets your app above those that don't. I'm going to highlight 3 best practices that you as developers can use to both increase user transparency and increase user acceptance of your permission request. These are choosing the right context to show permission requests, gracefully handling permission denials, and reducing permission usage where possible. The single most important thing apps can do to increase permission grant rates is to show permissions in context. Permission requests should be made at the point where users activate the feature of your app which requires that permission. Our research shows that users are 2 times more likely to deny unexpected runtime permissions compared to requests that they expect. So it is critical that at the point of request, the user understands what feature will be using their data and how that data will be used by your app. Let's look at an example. Here we have an app which allows the user to create notes. They have the option to take and attach a photo and a location to these notes. The first version of the app requests camera and location permissions at startup. This is a jarring experience for the user who very likely may not understand why a note-taking app would need these permissions. Now let's contrast this with the second app. This app has the same functionality, but it requests permissions in context. The app waits to request camera access until the user clicks the camera button, and waits to request location permission until the user clicks on the location button. This makes it much easier for users to understand what each permission will be used for. Now, sometimes it may be necessary to inform the user explicitly about how your app uses permissions. To facilitate this, the Android platform provides the should show request permission rationale API within ActivityCompat. If this method returns true, it's recommended to display additional information about why the permission is required before showing a permission request again. This is especially critical if your permission usage may not be immediately apparent to the user. When users deny permissions or grant less precise permissions, it is critical that your app gracefully degrade its experience. Unless your app is completely unable to function without a particular permission, it creates a very frustrating user experience if some functionality in your app is locked off behind a permission grant that the user sees as unnecessary. Therefore, your app should continue to function as best it can in the case that permissions are denied. For example, if the user does not grant location permission, Google Maps still allows the user to pan around the map, view information about individual locations, and manually navigate by specifying a start and an endpoint. A great way to avoid user denial of permission requests is to use less precise permissions or reduce usage of permissions altogether. This communicates to users that their privacy is being respected. For example, many location use cases do not require precise location access. And that's why we encourage you to only request coarse location unless the current feature that the user is actively engaging with requires precise location. Another way that apps can reduce usage of permissions is by choosing permissionless alternatives, like the action image capture intent to leverage the system camera app instead of requesting camera permissions. Apps can also now use the new revoke own permission on kill APIs mentioned earlier if they no longer require permission. For example, when using permission-protected data exclusively during the onboarding of a user. Now, it can sometimes be difficult to determine exactly where private data is accessed, especially in larger apps or apps that include bundled SDKs or other libraries, which may use permissions in ways that aren't immediately apparent. Android has introduced data access audit APIs in order to help apps detect which sections of their code caused a private data access and reduce these accesses where possible. Apps targeting Android 11 and higher can leverage these APIs by creating an on-op-noted callback object and registering it with the AppOps manager. After implementing this, your app will be notified about both synchronous, for example, microphone access, and asynchronous, for example, location, usages of permission-protected resources. Together, these best practices can dramatically reduce user denial of permission requests and increase user trust in your app. Now I'm going to hand it over to Terrence, who will be discussing some examples of these best practices in action.
Thanks, Nate. Now, the following examples show how Google's apps follow permission best practices. Hopefully, they will help inspire you in your feature planning and development processes to prioritize users' privacy. Let's begin with Gmail, which relies on notifications to alert users of new emails or messages. As a result, the Gmail team has carefully designed its notification permission workflow, including how and when to request a permission to optimize acceptance rates and user experience. Let's explore this together. First, let's cover the timing of permission requests. Earlier, we mentioned that apps should provide situational context for their permission requests, which means to prompt users when they're already ready to grant. In Gmail's case, they wait until the user completes the add account phase of the onboarding flow and lands in the inbox screen before requesting the notification permission. It doesn't make sense for the app to prompt for notifications before the user signs in. However, when the user sees a list of their emails in the main screen of the app, they're much more likely to understand why the app would like to send them notifications. Next, I know what you're all thinking. What if the user denies the notification permission anyways? Well, In that case, Gmail seeks to minimize the effect of that denial on user functionality and doesn't repeatedly show disruptive in-app dialogues to convince users to change their decision. Instead, Gmail allows these users to continue using other aspects of the app as normal, such as reading and responding to emails. However, this doesn't mean that Gmail gives up on notifying these users altogether, as often users may have accidentally denied the permission and are now wondering why they aren't receiving notifications for new emails. For those users, the app provides a robust troubleshooting path to re-enable the notification permission in the app settings page and when users attempt to change individual notification settings. Since it's likely users who are troubleshooting why they aren't receiving notifications will visit Gmail's settings page, Gmail has embedded several notices there. These notices alert users that notifications are currently disabled for the app and provide them with the link to easily re-grant the permission in system settings. Similarly, if users try to modify the notification settings for emails or chat messages with notifications disabled, they get a prompt with the same information and settings link. As we can see, Gmail seeks to provide a great user experience to users who knowingly opted out of receiving notifications from the app while still providing a robust path for users to resume receiving notifications if they choose. Let's pivot a little and explore how Google Maps, an app that is closely associated with location, works hard to deliver a great experience when requesting permissions. First, Maps requests permissions in context as the user tries to navigate to a particular place, since this is when they're likely to understand how they will benefit from granting location access to the app. Another way users can provide or upgrade Maps location access voluntarily is by tapping the Current Location button in the bottom right corner. This signals to Maps that the user is likely ready to grant upgraded access, so the app can locate them. However, even if Maps follows all the permission best practices, there will always be certain users who might prefer to share only approximate location or no location information at all. For users who don't grant any location permissions, Maps will start by showing a broad view of the world the first time the app is launched. From there, users can pan around the map or zoom into particular areas of interest, and they can click on particular locations or shops to see more details like reviews and images. If users search for a particular keyword, they will still get results that are relevant to the area of the map that they're currently viewing. To provide navigation capabilities without location permissions, Maps allows users to type in the origin and destination addresses. Users will still be able to find a route between the 2 points and can view a list of navigation directions. Here, for example, you can see a route between one of Google's San Francisco offices and my home. Oh, where's home for me, you ask? The Android Statues Garden in Mountain View, of course. I mean, where else would it be? Some users may decide to grant Maps access to only their approximate location, which provides an estimate of their location within a 3-kilometer radius. In this case, Maps uses that estimate to provide a better user experience. This is evident as soon as the user launches the app. Maps centers the estimate of their location instead of a broader view. When the user searches for something, such as shopping, Maps uses estimates of the user's location to provide more relevant results. That's not all. When the user clicks on a location of interest, Maps can provide an estimate of how far away that place is from them so they can plan their trips accordingly. Now, let's take a moment to summarize everything that we've discussed today. Here are the main takeaways for developers. Protecting user privacy is a top priority for Android and our ecosystem, and permissions are an important way we help users stay in control over their data. We rely on you, the developer, to protect the privacy of your users and improve their experience with your apps by adopting our best practices for permission. These are increasing situational context of permission requests, properly handling reduced data access, including from permission denials, and lastly, requesting only the permissions that your app really requires. We hope that Gmail's handling of the notification permission and Google Maps' handling of location permissions will help serve that purpose. If you'd like to learn more about specific permissions and features that we've discussed in this talk, such as location accuracy or data access audit APIs, please check out our revamped landing page for all privacy topics in Android at d.android.com/design-for-safety. Also, check out the Everything to Know About Storage ADS talk if you want to learn more about how to handle app storage in a way that respects the user's privacy. Hope to see everyone there. Thank you so much for listening.
My name is Erin Walsh, and I'm a Developer Relations Engineer on the Privacy Sandbox team here at Google. Today, I'll be talking through what's next on the Privacy Sandbox on Android. In this talk, we'll start with a brief refresher of what the Privacy Sandbox entails and when to expect new releases and features. Then we'll walk through a couple ad tech use cases and how to implement them with the Privacy Sandbox APIs. Finally, we'll review some resources to help get started with integration. The Privacy Sandbox aims to improve user privacy without putting access to free content and services at risk for the mobile ecosystem. To do this, we have topics, Fledge, attribution reporting, and the SDK runtime. The Topics API gathers on-device information to infer topics of interest to a particular user, which advertising SDKs can use to serve relevant ads. The Fledge API orchestrates ad selection workflows and shows ads based on custom audiences defined by app developers. The Attribution Reporting API supports the measurement of clicks, views, and conversions, and sends the reports to advertisers that detail the performance of an ad. The SDK runtime allows third-party ads-related SDKs to run in a dedicated runtime environment that provides safeguards around user data collection and sharing. These APIs allow you to monetize your app with relevant and high-performing ads while still protecting the privacy of your users. App developers can typically work with their advertising SDK partners to integrate the Privacy Sandbox. Since our initial announcement in February, we've been busy releasing developer previews, which allow you to integrate and test all of the APIs that I just mentioned. Right now, you can check out what's new in Developer Preview 6. We plan to enable testing of the Privacy Sandbox on public mobile devices in early 2023. We'll also release our first stable API release and a future SDK extension for you to integrate. After that, we will continue releasing developer previews in parallel to stable API releases to expose the latest features. To test against developer previews and stable releases, developers will need to complete an enrollment process that enables access to the Privacy Sandbox. When the first stable API is released, the Privacy Sandbox will initially be made available on a small percentage of eligible Android 13 devices. So, when is the best time to start testing the Privacy Sandbox? The answer is right now. The sooner developers can start incorporating the Privacy Sandbox, the more action we can take on any feedback that you might have during your integration. We need your help to make the best product that we can. So now that we've had a recap of what the Privacy Sandbox is and where we're at in development, let's take a look at some practical examples using the Privacy Sandbox APIs. These examples demonstrate a few of the many ways you can put the Privacy Sandbox into practice. Ad tech developers want to know what users are interested in, so they can serve ads that are interesting and relevant to the people seeing them. To do this, they can use the Topics API to receive a list of interests that are relevant to the user of an app. The Topics API infers these coarse-grained interests on device with added noise to protect user privacy. It is encouraged to start integration with the Topics API and work with advertising partners to include topics in ad requests so they can be used for ad selection. To do this, first instantiate the Topics Manager. Then instantiate the topics request builder, which can be used as is or populated with options for the request. Then the topics manager can be used to call get topics and will return a callback. The topic objects will include a topic ID, which corresponds to a taxonomy entry. In this case, our user is interested in cats, concerts, and winter sports. You can view the full taxonomy on our Privacy Sandbox GitHub page. Advertiser apps want to select the best possible ad to be shown in other apps on the same device. To do this, they can use the Fledge API to add a device to a custom audience based on the actions that a user takes. The custom audience carries information for candidate ads and logic to determine which ad to display. Let's say the user accesses this children's menu in a restaurant app. This action would be a good trigger to join the device to a custom audience for families with children. In addition, the restaurant app lets the ad network that manages its ads know about this custom audience. This can be accomplished with the Fledge API by creating a custom audience. This will include information such as the name of the ad network that manages your ads, where the ad network hosts your ad content, and the name of the custom audience itself. In this case, families with children. Once the custom audience has been defined, it can be used to create a custom audience request. Then the custom audience manager can be instantiated and used to make the call to join custom audience with the request that was just created. Now this device is part of the families with children audience. Now that we have a custom audience on this device, a publisher app on the same device will want to consider the ads that are associated with that custom audience when choosing an ad to display. To do this, the publisher app's ad network SDK can use the Fledge API to call select ads. Let's say the publisher app is a travel guide app. This travel guide app wants to display ads while the user researches attractions, landmarks, and restaurants. The travel guide's ad network SDK will start by building an ad selection config to set up the auction parameters. The builder can be used to set variables for ad selection. The ad network's SDK can use these variables to pass signals that are relevant to the advertising slot that the auction wants to fill. For example, what kind of food the user likes. After creating the builder, instantiate the ad selection manager, then use the config that was just created in the call to select ads. This will start an auction process that decides which ad will be selected to be displayed in the publisher, in this case, the travel guide app. The ads considered for this process will come from the custom audiences present on the device. In this case, the families with children custom audience from the restaurant advertiser app. The auction will run and a winning ad will be selected, which could be the ad from the families with children custom audience. Because the custom audience is not shared directly between the advertiser and publisher apps, Fledge can perform ad selection while protecting user privacy. To implement an end-to-end ad selection process, it is important that the advertiser app and publisher app work together. This implementation of the Fledge APIs has been simplified for time. We did not get into the details of what happens when an auction is run. I highly encourage you to check out our documentation for more details. After an advertisement is displayed in an app, ad tech developers will want to assess how well the ad is performing. This can be done with the Attribution Reporting API, which accomplishes ad measurement goals without the need for cross-app identifiers, which limits information ad tech companies receive about users. The Attribution Reporting API receives information about how the user is interacting with an advertisement from an Android app, SDK, or Chrome mobile browser. Once this information is gathered on device, the Attribution Reporting API sends reports to a designated service. This service is set up by whomever is receiving the reports, for example, a mobile measurement partner. Let's say a user views or clicks an advertisement in your app. You can record these interactions with the measurement manager's register source function. Register source calls an endpoint from the ad tech service that is enrolled with the Privacy Sandbox, and this endpoint can include optional identifiers to include more information about the interaction, such as the identifier of an ad campaign. After the user has seen or clicked the advertisement, let's say they were inspired to purchase the product being advertised. You'll want to record this action as a conversion. You can do this by invoking Measurement Manager's register trigger function. Similar to register source, you'll pass register trigger an enrolled endpoint from the ad tech service and can include optional identifiers. Now that you've registered a user's interaction with the ad, you will want to receive and interpret that data. The data that gets sent to the ad tech service in the form of event level and of aggregate reports. Let's take a closer look at the information in each report. The event level report contains information about specific conversions that happen on the device. Because these reports refer to specific conversions, the information in these reports is limited to protect privacy. You'll find information such as the attribution destination, which refers to the app in which your event happened, the source event ID, which refers to the ad that led to this report, the trigger data, which is low-fidelity data for conversions, the source type, which refers to whether the interaction is a click or a view. In this case, navigation refers to a view, and the randomized trigger rate, which is a parameter for adding noise to event reports. The aggregate report details how well your advertisement is doing overall. There are many ways to measure the success of an ad based on different business needs, so the aggregate report is customizable depending on what you want to measure. For example, if you want to measure how many purchases of a product were made in a certain geographic region due to an ad campaign, you can design an aggregation key to measure the amount of purchases based on those categories. The payload will return an aggregate key referring to the ad campaign, geographic region, and product, and the aggregatable value, which in this case refers to the amount of purchases made in those categories. In practice, the payload information will be encrypted in the report and bundled along with some other information about the report, such as the reporting origin, which lists the URL where the report was sent. You can learn more about designing and receiving aggregatable reports on our documentation. Now that you've seen some examples of the ways that you could choose to implement advertiser use cases with the Privacy Sandbox, we encourage you to go try out the APIs. You can find sample apps on our GitHub page, development guides, and videos to help you get started. Please reach out if you have any feedback for us along the way. The earlier we receive feedback on the Privacy Sandbox, the better we can address it to make the best product possible. Thank you so much for watching.
A QA engineer walks into a bar and they order a beer. They order 0 beers. 9,999,999 beers. They order a rubber duck, -1 beers. A chocolate milk. Satisfied, they give the go-ahead for the bar to open. A week later, the first real customer walks into the bar and asks where the bathroom is. And the bar bursts into flames. As software developers, there is no end to the number and types of cases that we're asked to handle. And it can be difficult, if not impossible, to craft an app that accommodates all of these scenarios. Hi everyone, my name is Nevin, and I'm a developer relations engineer on the Android DevRel team. In this talk, I'd like to talk through some tools and steps you can take in your media app to make sure that you're presenting a high-quality experience for all your users. It goes without saying that media is ubiquitous in our lives nowadays. Whether you like to settle in for a cozy audiobook night, tune in to your favorite TV show after work, or just listen to music while folding the laundry, our media follows us everywhere. Users expect their media to be quickly and easily accessible from their phones and their watches, on their TVs, and in their cars. You might have to deal with low connectivity, or the device might have the latest and greatest specs for you to work with. And then there are behavior changes introduced with each Android release, and new features being introduced every year. Media is a rapidly evolving space, and it can be difficult to keep track of everything. You can abstract away tons of complexity by using a library that can handle this device and API fragmentation for you, and instead presents you with a single common API that works across all of these cases. For media apps, look no further than the Jetpack Media 3 library. Even compared to previous iterations of the media APIs, Media 3 offers a simplified API for you to use. For example, there's a single common player interface that's used across many key components, such as media session and media controller, which makes it easier to follow exactly what's going on when you're trying to handle, say, a play command. Important information, such as the state of playback and the metadata of the currently playing media item, are automatically kept up to date so that all of your clients remain in sync. Media 3 is also where we're introducing new capabilities, such as the ability to specify which playback commands are available to media controllers on an individual basis. In addition, we're expanding beyond playback use cases with a new module called Transformer for video editing and transcoding use cases. But perhaps as you consider Media 3 for a current or upcoming project, what's more important to you is what's staying the same. Media 3 is fully backwards compatible with legacy APIs such as Media Compat, so that all of your existing integrations will continue to work. Media 3 also retains the customizability and modularity that developers enjoy with projects such as Exoplayer, which itself is now a module within Media 3. And if nothing else, Media 3 is the new home for future development of the media APIs and is where our efforts are invested going forward. Let's take a closer look at a couple key components in Media 3. Exoplayer is Media 3's default implementation of the Player API. Note that if you already use the standalone Exoplayer, Media 3 Exoplayer is identical and just requires a package name change if you're using a recent release. Exoplayer offers out-of-the-box support for traditional player functionality, such as playing, pausing, and skipping media items, but it also includes APIs for features like playlists, ad insertion, adaptive streaming, and DRM. You can check out our previous talks discussing Media 3 for a more detailed introduction to the library, but for now, I'd like to demonstrate how you can use Media 3 with your own custom player if you choose to do so. Media 3 offers a simple base player that minimizes the number of methods you need to implement to integrate with a custom player. Start by overriding the getState method, which is where you can declare what commands are supported by your player and configure some metadata, such as the currently playing media item index and the timestamp that you're currently at. Any methods related to commands that you don't declare as supported will be ignored. So beyond the getState method, you'll only need to implement the methods that will actually get used. Subclassing the simple base player also grants you some additional conveniences, such as state value validation and listener handling already being set up. Once you have a player, you can implement a media session. Media session is a key API for cross-surface consistency across Android, as it allows you to broadcast playback information to the entire system and also receive playback requests from other clients, which may include headphone or remote controls, system-drawn playback controls, or the Google Assistant. Media session is technically optional, though without a proper implementation, your user's experience is likely to be degraded. They may not be able to easily access their media through Android Auto while on a drive, or they may not be able to control their songs while out on a run from their watch. To this effect, we recommend structuring your project in Android Studio so that you can reuse your Media 3 code as much as possible, instead of trying to manually re-implement the media session the same way every time. By compartmentalizing common components, such as your player and media session in a separate module, you can reuse your implementation across all the surfaces you support. Code once and build twice. Next, I'd like to talk about Performance Class, a tool that you can use to make sure you're presenting the best experience to each user on a device-by-device basis. There are billions of Android devices out in the wild, with varying hardware specs, capabilities, and software implementations. So how can you be certain that your app will perform well no matter what? Rather than scaling down app experiences for the whole ecosystem to accommodate lower-end devices, one option is to define groups of devices that perform similarly. This way, for example, you could specify that your app does full resolution playback on high-performing devices, but reduce the resolution on lower-performing devices to make sure that the playback stays smooth. Another area where device clustering can help is to focus your debugging efforts on the groups of devices that are most affected. For example, let's say you notice that an issue mostly happens on mid-tier devices, but doesn't seem to affect the low-end or high-end market. You can refocus your testing efforts on those devices specifically, saving you time and effort. For each version of Android, starting with Android 12, the Compatibility Definition Document, or CDD, defines the performance class as a set of optional additional requirements. These requirements are verified by the certification test suite so that each device build is assigned a performance class level if it passes the corresponding criteria. Requirements include a number of items that media apps would be interested in, such as screen resolution and density, codec support, and startup latency. The recommended way to access a device's performance class level is with the Jetpack Core Performance Library. This library extends performance class back to Android 11 and also assigns performance class to devices that don't declare their own based on certification test results. Note that the library is currently in alpha, but we look forward to releasing the beta version soon and encourage you to try it out. In this example, we start by first creating an instance of device performance in the onCreate method. Then, we can use the device's performance class level to adjust the video encoding resolution, using a higher encoding height for devices with higher performance level. Even if you don't use performance class to turn features on and off in your app, performance class can be an additional helpful signal to include in your telemetry to better understand how your app is performing based on different device characteristics, especially as you look to optimize your app for newly launched devices in the market. Now, at this point, I've shared a number of strategies to help you ensure that for one user on one device, they can thoroughly enjoy their media no matter what the scenario is. Let's take a slight pivot to look at the content generation side of things and discuss how to make sure your content remains high quality as it travels from device to device. There are, of course, multiple factors that can impact visual quality. OEMs define the camera features and other specs available on a device. The SoC affects encoder efficiency and reliability. Android platform offers APIs and tools for you to use, and it all converges on you, the app developer, who decides what your media pipeline looks like. Optimizing when and how your media is processed can have an immediate and noticeable quality impact so that your content remains crisp. The typical media sharing pipeline can be split into 4 broad steps. We start by capturing some media. This is where the image, video, or audio is initially encoded, and the goal here is just to capture the best quality we can. Next, there might be some editing involved. You might layer elements on top of your content, such as adding filters, captions, or effects, or you may be transforming the media by cropping or scaling. Ultimately, throughout all of these edits, the main thing we want to do is preserve as much of the original quality as possible. After this, the content is likely to be uploaded somewhere. This is the step where you can perform further transcoding to try and optimize the content for multiple consumer devices. And lastly, the content is downloaded to a device for playback, ideally with minimal touch-ups required on the receiving end. Let's take a closer look at the middle 2 steps in this process, editing and uploading. When it comes to editing, optimizing the order of operations can help you preserve quality in the areas where it most matters. For example, let's say you're recording in the standard rectangular aspect ratio, but you really only care about the square in the middle. By cropping the content to a square before doing any further encoding or editing, you'll avoid wasting resources on the portions of the video that don't matter. Another common transformation is to scale the content up or down. Scaling almost always degrades quality significantly, so ideally, you should be recording at the target resolution to begin with. At the very least, aim to keep resolution changes to at most 1 operation in the entire pipeline, and make sure to use efficient algorithms such as bicubic scaling. For the upload step, you can retain quality by making sure you're compressing the content as efficiently as possible. On Android 10 and up, you should include B-frames in your uploads to improve compression efficiency and video quality. Similarly, aim to use newer codecs whenever and wherever possible to get files that store higher quality content in fewer bits. In addition, use the highest profile possible provided by the codec to take advantage of features such as B-frames. We're investing in supporting modern codecs, both by including and improving software codecs in the platform, and in the longer term by working with device manufacturers to include hardware-based codecs. New format requirements are part of the CDD and generally announced via an Android developer blog post so that you can stay up to date. Especially if you ingest or consume content from shared storage, make sure you have a way to decode new formats. Formats that can be used for capture by the native camera app are a great place to start. It goes without saying that new codecs and formats are introduced because they are better in some way. So we encourage early decoder adoption. And it doesn't need to be an all or nothing decision. You can gradually add support by starting with lower resolutions or by rolling out support to a subset of devices. The Media 3 Transformer library I mentioned earlier can be helpful when making sure your app is able to handle content in new formats. For example, in cases where you ingest content from external sources. Let's start by taking a look at a simple example of how to use Transformer. First, specify the output type you want. Then, build a transformer, passing it the request and a listener. The transformation happens asynchronously on a background thread, so the listener has callbacks for completion and error cases. And lastly, start the transformation. Finally, I'd like to briefly touch on some of the premium features that Android has added more support for recently that you can integrate with to take your app to the next level. Android 13 introduced standardized platform support for HDR, including APIs for capture, sharing, editing, and playback. For playback of HDR video, you can use display.getHDR capabilities to check which HDR profiles the device supports. To play HDR video, you'll need to render your content to a surface view. Texture view will only display video in SDR. Exoplayer is the recommended way to play HDR video, since its default UI components already use surface view. For any use cases where you need to convert HDR video to SDR, you can use Transformer by enabling the SDR tone mapping flag when building the transformation request. This will currently work on devices that support HDR capture, but we're working on extending this functionality to devices that don't support HDR capture as well. Alternatively, the Transformer API currently includes an experimental API for editing HDR video streams directly. With this flag enabled, Transformer will attempt to edit HDR streams as HDR. This feature is currently under development, and we're looking for your feedback, so please try it out and let us know if you run into any issues. For more on implementing HDR video from end to end, check out Ray's talk on HDR video. And lastly, spatial audio, which refers to a technology that creates a sound field surrounding the user. This allows them to hear differences in audio channels and sound positions through just the two speakers of a headset. Advantages of spatial audio include more immersion and realism, clearer dialogue, and a better listening comfort. In Android 13, we introduced standardized platform architecture that enables lower latency and codec-agnostic spatialization of multi-channel audio. For developers, we have the Spatializer API to help you check the current device's capability to output spatialized audio. Here, we're checking for 4 criteria. First, does the device support spatialization to begin with? Next, is spatialization currently available on the device? Then, is spatialization even enabled? This is controlled by the user through a system-level setting. And lastly, is the currently playing audio track eligible for spatialization? This can be affected, for example, by whether the audio is being routed through a supported output device. If you use Exoplayer, this logic is already handled under the hood in the latest release. The player will automatically select the appropriate audio track from your file based on the device's capabilities. Hopefully I've shared at least one tip that will help you improve the quality of your app, and I look forward to seeing the delightful experiences that you continue to build. Thanks for your time.
Hey everybody, I'm Karen, an engineer on the Android Developer Relations team, and today I want to spend some time to talk about accessibility and compose. All right. Hey everybody, I'm Karen, an engineer on the Android Developer Relations team, and today I want to spend some time to talk about accessibility and compose. Sorry, the speaker notes are not there. No worries. I wish I had a joke.
That was perfect. Look at that. The audience laughing.
Should we start over? All right. So, hey everybody, I'm Karen, engineer on the Android Developer Relations team, and today I want to spend some time to talk about accessibility and compose. So we're going to start by talking about the different ways to think about accessibility for your app, and how Android Framework enables apps to be more accessible for a wide range of users. Then, building off of that, we're going to talk about how Compose was built with accessibility in mind from the start, and how you can make your Compose apps more accessible. Finally, we'll end with a couple of best practice tips that you can keep in mind in the future as you're developing apps. All right, so to start off, I wanted to give a quick overview on the different ways to think about accessibility. The first aspect to consider is the design of your app. So this means making sure that all the elements in your app are easily visible and interactable. And this is important because it makes it more accessible for all the users in your app. Another aspect to consider when thinking about accessibility is whether your app works well with the different assistive technologies. So sometimes we forget that not everybody interacts with the device the same way. And sometimes users may be using devices like keyboards or services like screen readers to help them interact with their device. So when you're considering accessibility for your app, it's important to also consider whether your app works well with these different types of services and devices. So today's talk, we're mostly going to be focusing on the assistive technology side so that we can build a better understanding of how our Android apps interact with accessibility services and how you can make your apps to be more accessible for the wide range of users your app has. All right, so the best way to start thinking about supporting the variety of users in your app is by looking at the different ways a user can interact with an app. So here we have a simple app with a checkout button, and we're going to look at the different ways a user can interact with this checkout button. The first and most common way that I think we're all familiar with is by tapping on the checkout button. However, sometimes a user may be using TalkBack to interact with their device and therefore your app. So TalkBack is a screen reader that helps users with vision impairments navigate their device. Using TalkBack, users can interact with the device using swipes and gestures and hear spoken announcements about what's displayed on the screen. So if a user was using TalkBack to interact with our app here, they would navigate to the checkout button with swipes, and then they would hear the announcement checkout button, double tap to activate, and then they could double tap anywhere on the screen to activate the checkout button. Voice access is another accessibility service that some users use to help them access their device. Voice access allows users to control their device with spoken commands. So if a user was using voice access to interact with our app here, they would give the voice command tap checkout, and similarly, that would activate the checkout button. So here we've seen 3 different ways to interact with the checkout button here, but of course there are many other different ways that the user may be interacting with this app based on which accessibility service they're using. So the question now becomes, as an Android developer, we only built our simple app in one way, and we didn't really think about how it would interact with these different accessibility services. So how does that actually work? Well, most of the work starts in Android Framework. So what Android Framework does is it takes a look at your app and it translates it in a way that allows different accessibility services to adapt your app based on the user's needs. In order to do this, what it does is it creates a tree of nodes that reflects what's currently displayed on the screen. And each of these nodes is referred to as an accessibility node info. So accessibility node info contains a lot of details about that specific node, but I want to highlight 2 of the most important pieces of information it contains. The first is the label. So for example, the content description that you set on an image button to describe the purpose of the button. The label is really important because it allows users to understand the purpose of each element in your app. The second is the set of actions that are available on an element. So for example, for every element, we need to know whether there are actions like tap or long click, or if it's some kind of text view, is there an edit action available? The actions allow accessibility services to know how the user can interact with the element. And you probably have never needed to think about accessibility node info or the properties contained inside it, mostly because these properties are filled in automatically for you if you're using built-in components. So for example, the framework automatically populates the label text field for text elements and certain actions for specific widgets like the switches or radio buttons. And so it's with all this information that then allows TalkBack to make announcements based on the element's label and available actions. And similarly, because of all this info that accessibility node info contains, accessibility services are then able to navigate and interact with apps. And Android Framework creates this tree of accessibility node infos because it wants to help developers represent their app for accessibility services, but also you as a developer have the capability to access the tree to create accessibility tools to support more users. All right, so now that we have a better understanding of how the framework works with your app to enable different accessibility services, we're going to dive into how this all translates in Compose. We're going to start at the beginning at what happens when you create composable functions. So when you create composable functions and the composable is evoked, a composition is created to describe your UI. As part of the composition, a semantics tree is also generated. So this semantics tree is especially important for us in this talk because it contains all the information about the meaning of each node. And some of the information it contains includes the label of each element, the actions that each element has, or what kind of component it is. And similar to the old view system where accessibility node infos were automatically populated for you if you're building using built-in components, the semantics tree is also automatically generated if you're using components from the Compose Foundation library or the Material library. And so it's with the semantics tree that the accessibility node info tree is then able to be generated that is then able to power accessibility services. What this means is that composables with no meaning are not included in the semantics tree, which is then not seen by any accessibility services. So here's a more concrete example where we have a composable with a column. The composable includes a button, an image, and a box. So the button has an on-click action associated with it, so it has some kind of meaning, so it's included in the semantics tree. The box has a content description or a label included with it. That means it also has some kind of meaning, so it's also included in the semantics tree. However, the image, as you see, is only associated with the drawable. That means it has no meaning in terms of actions or labels, and therefore it's not included in the semantics tree, and therefore not seen by accessibility services at all. And the reason that Compose doesn't include elements with no semantics is because omitting these type of elements with no meaning improves the navigation for users of accessibility services. This allows them to more easily navigate through your app by interacting only with the meaningful elements. What this means is that sometimes Compose finds the need to merge nodes. So sometimes Compose merges nodes by grouping certain content together to enable easier navigation. And this is automatically applied for things inside a list, so any items inside a list are automatically merged, and also any elements inside a composable with a clickable modifier are also automatically merged. Sometimes you might find the need to specify your own merging behavior for your composables. So a more concrete example, as we see here, is an element with a drawable and some text. So if we don't specify our own merging behavior in this example, accessibility services will see these three elements separately as the image and the two pieces of text. However, because it might make sense to group all this content together, something we might consider doing is to set the merge descendants property to true. That will allow accessibility services to see this element as a whole instead. And similar to what we talked about before, another way to achieve the same result is by adding a clickable modifier to this whole element row in order to merge it all together. But something to keep in mind is that if you're specifying merging behavior, descendants that are set for merging are not merged with its parents, which might be kind of hard to parse. So let's take a look at an example. So here we have a clickable button, the bookmark, inside a card, which also has its own clickable action. As we mentioned before, if you apply a clickable modifier to an item, it automatically merges them. But here, since the bookmark button has its own click action, it doesn't want to be merged with the card. That would get rid of the click action of the bookmark. So here, the bookmark button preserves its own click action, and the card also preserves its own click action. Something else to consider when you're specifying merging behavior is semantics properties. The first is that semantics are additive, and that means that when you group together composables, all their semantics are combined. So here is a more concrete example. This is the one that we looked at last time, where we grouped all the elements together because they made sense to be grouped together with the clickable modifier. So something we might consider doing to take it a step further is then add a content description to the image. When we add the content description to the image, it will be combined with the labels of the text because it's all part of the row. If you can't achieve the desired behavior just by adding semantics properties, sometimes you might need to use the clear and set semantics method instead. So going back to our last example, after we merge it, we might find the need to specify the order in which the content description is read aloud. So for that specific use case, we could use the clear and set semantics method to further specify how we want the content description to be laid out. And if you ever want to take a closer look at the semantics tree for your composables, you can always use the layout inspector in Android Studio. And for each node in the semantics tree, the layout inspector will show you the specific semantics set on that node. Similarly, you could also use the print to log method in your compose test to log the full semantics tree and see it printed out. But the important thing to remember here is that if you're using components, they support accessibility out of the box, so you hopefully don't have to worry about most of this. If you're building your own custom components, however, such as your own radio button or your own checkboxes, that's when you want to pay closer attention to accessibility support. And a good way to do that is to check out the material components implementation to better understand how to utilize the Compose Foundation library that does have the accessibility support to build off of that. And a more concrete example is, for example, if you wanted to build your own text field, a good way to start would be looking at how the text field is built in Material 3 based on the basic text field from the Compose Foundation library. All right, so to wrap it all up, we're going to end with a few general accessibility best practice tips to keep in mind for the future. The first is to design for accessibility. So if you consider accessibility from the start, this builds solid foundations for your app to support accessibility in the long run. Next, always remember to label your elements. Having concise and precise labels helps all your users understand the purpose of each element. And finally, if you can, always try to manually test. Testing your app with an accessibility service such as TalkBack helps you understand the areas for improvement. As always, we're listening to your feedback, so if you have any suggestions about how to improve Compose and accessibility, feel free to file an issue. And that's it for me. Thanks for listening to this talk, and thanks for your interest in accessibility.
Hello everyone, I'm Thomas Aizan and I'm an Android developer relation engineer working on machine learning. So with the rising processing power in mobile devices, it's now possible to run machine learning features and process sound, text, images, or even videos directly on the device. But providing low latency for live experiences can be hard. And so today I'm going to talk to you about how hardware acceleration can help. So we will start by reviewing the chips that are available on mobile devices that can enable hardware acceleration. And then we'll look at examples, and one in particular, which is the post-detection algorithm. And finally, we will see how we can use hardware acceleration for a machine learning feature in your own application. So let's review the hardware that is available on mobile devices. So it might actually feel strange for mobile developers to consider the hardware your application is going to run on. Usually when you create a traditional app, you rarely think about the chip that will execute your code. Most of the processing power happens on the CPU, which is versatile and available on any mobile devices. But with machine learning apps, going beyond the CPU and accelerating your machine learning features on specialized hardware can actually make a huge difference. So for instance, by using specialized hardware, you can divide your inference latency by 10 and enable live experiences like the post-detection or augmented reality filters. And you can also offload the CPU workload to other chips. And finally, you can reduce the battery impact as some hardware consume usually less power than the CPU, like the DSP, for instance. So we can group those specialized hardware in 3 categories. There are GPUs, graphical processing units, DSPs, digital signal processors, and NPUs, neural processing units. So GPUs are often used for graphical rendering processes, but they offer high throughput and massive parallelization, which is very handy for machine learning processes, especially if you want to enable real-time experiences. And they are also capable of handling floating point calculation. So you can reach good performance without having to quantize your model. And actually, the GPU is often the most popular hardware for machine learning acceleration for Android developers. Then there are DSPs. They are mainly used for analog to digital and digital to analog conversion of voice and sounds. They are designed to handle math-heavy processes, and they are also optimized for energy consumption, or low energy consumption. And finally, there are not chips that are designed and optimized for executing machine learning, such as NPUs and TPUs. And so after revolutionizing machine learning and inference in the cloud in the past few years, those chips are now becoming available on mobile devices. So currently, they are mostly available on higher-end devices, but they are becoming more and more popular. And for example, the Google Pixel 6 and 7 series embed the Google Tensor, which enables some key, the acceleration of some key Pixel features, such as mobile eraser and on-device translation, which are available on other devices, but are optimized to take advantage of Google Tensor chips. So if we can summarize, CPU isn't always the only processing unit available on a mobile device. And depending on your model characteristic, you can use a GPU or a DSP, or if the device has one, use NPU, TPU chips to offload the computing load from your CPU and accelerate inference. So we reviewed the different specialized chips available. Let's now zoom in and see how acceleration can be helpful in a concrete example. So if you want to run machine learning inference on Android today, there are several options available. So if you have some machine learning expertise and you need advanced control over the user experience or the machine learning process execution, you can use TensorFlow Lite. On the other hand, if you don't have machine learning experience and you want an easy-to-use solution, you can take a look at the MLKit SDK. MLKit is actually built on top of TensorFlow Lite, but it offers machine learning-enabled APIs that are optimized for mobile and production-ready. So if you decide to build your own custom ML solution, TensorFlow Lite is actually available via Google Play services. So you don't need to bundle it with your app, and it is actually guaranteed to run the latest stable version of TensorFlow Lite. And besides, TensorFlow Lite in Google Play services is now the official machine learning inference engine on Android. So using it in your application will let you benefit of future APIs and services from Android's custom ML stack as they will be built on top of the inference engine. And it's already used by thousands of apps and more than 1 billion users monthly. So a few years ago, Google released Blaze Pose, which is a model following a new approach to human body pose perception. And it works in real time in videos or static images. And the model returns positions of body points such as knees, shoulders, hands. So depending on your use case and the level of expertise, if you want to use Blaze Pose, today you can either download the Blaze Pose Lite model and use it with TensorFlow Lite, or you can directly use the MLKit pose detection API and use the API basically as a ready-to-use solution. And if we actually take some time to look at the performance of the MLKit pose algorithm and look at the benefits of hardware acceleration, we can see that when the model is executed on GPU, we are basically seeing the inference is running 184% faster than when we run it on the CPU. And if we run it on a TPU, then it's even faster, and it's basically 200 faster than the CPU. So that's one example of the benefits of hardware acceleration. But there are models that are even more optimized to take advantage of GPU acceleration. And for instance, if you use MobileNet, which is an image classification model, you can see up to 10x latency improvement. So we discussed of the benefits of enabling hardware acceleration for inference. If you are using MLKit, you really don't need to do anything. MLKit is already configured to get you the best performance you can on the current device. But if you want more control, let's review the step to add GPU acceleration for TensorFlow Lite with Google Play services to your application. So the first step is to add the dependencies to your build.gradle file in your application. So make actually sure that you migrated to TensorFlow Lite with Google Play services. And you can read more about it in the TensorFlow Lite documentation on tensorflow.org. And then actually, like for TensorFlow Lite, the GPU support can also be provided via Google Play services. And the benefits are the same. It reduces your app size, and it also enables you to run on the latest stable version of the GPU support. And you can note here that we are using a package name that starts with com.google.android.gms, which is for the TensorFlow Lite GPU dependencies. And that indicates that the GPU support implementation is provided via Google Play services. Then in your Kotlin code, you will initialize the TensorFlow Lite instance with a Google Play services task. And you will then call set enable GPU delegate support true on your TensorFlow Lite on your TF Lite initialization options to enable the GPU delegates. If the initialization is successful in the callback, you will call the add delegate factory on the interpreter option, and you will pass an instance of GPU delegate factory. So the code I walk you through lets you create a TensorFlow instance using the GPU delegate and enable hardware acceleration. But in addition of just enabling it in your code, you can also adapt your model to leverage the GPU. So for instance, one thing you can do is actually consider using a model that is optimized and built to take advantage of GPU acceleration and adapt it to your specific use case. So for example, I was just talking about ModelNet that you can use for image classification. You can also look at DeepLab for image segmentation, or you can look at PoseNet for pose estimation. And it's actually an alternative to Blaze Pose that I just talked about before. So it's optimized for GPU acceleration. Keep in mind that it detects less key points than Blaze Pose does. And then the second step you can take is to make sure that you avoid some specific operations. For instance, the reshape operations, such as batch to space, for instance, you probably want to avoid using them on the GPU. They are quick on the CPU, but they are particularly expensive to run on GPU. And also, another thing to keep in mind, GPU are designed to process images and texture using RGBA, which is coded on 4 channels, the red, green, blue, and alpha channel. And so if your model is actually using 4-dimension tensors as input, it's going to be significantly faster to run it on GPU. And you can learn more about how to optimize your model for the TensorFlow Lite in the TensorFlow Lite documentation. And for even more insights, you can actually take a look at the TensorFlow Model Analyzer command line tool, which enables you to evaluate the GPU compatibility on your model. And so, for instance, you can see an example here of the command line, and you need to pass GPU compatibility equals to true to have GPU compatibility specific insights. You can learn more about it in the TensorFlow documentation, and there is even Colab notebook that you can use to get familiar with it. And I talk about how to enable the GPU delegates, which is a great way to enable acceleration. But keep in mind that the GPU is not the only way for you to enable hardware acceleration. And you can take a look at the neural network API delegates to enable inference on DSP or NPU. Same thing, that's also something that is documented, very well documented in TensorFlow documentation. So to fully benefit from hardware acceleration, you need to make sure that your model is using operations that are supported by the delegates. And you can review the list of operations supported for each delegate, again, in the TensorFlow Lite documentation. And also remember that the acceleration delegates don't support yet the custom operations that you created yourself. And actually, if one of those operations in your model are not supported by the delegate, you will get the following error at runtime. And so what's going to happen is that this specific operation is going to be executed on the CPU instead. So if your model is actually splitting the execution between the CPU and the GPU, the back and forth is likely going to significantly increase the execution time. So for some cases, it might be better to either fully run it on the CPU or to re-engineer your model to make sure that it only uses supported operations. And so, as you can see, hardware acceleration is very much the way to increase execution performance, but it can be a complex task, and finding the optimal processing unit in your model sometimes can be difficult. So that's why we are currently building an acceleration service for Android. And so the way it's going to work is that you will be able to pass your model, your sample, some sample inputs, and also the expected results. And the acceleration service will then run a benchmark to evaluate the optimal hardware available on device and tell you basically which of the CPU, DSP, or NPU, if it's available, you should use to run inference. And so this is something that is currently in early access. So we are accepting applications, and we aim to ship it publicly early next year. And you can go to the ML Android developer documentation to learn more about it. So we covered a lot, and you can see that you can already use hardware acceleration in your application today. But we are actively working on making the process even easier in the future. So ML in general and ML in Android is a field that is constantly evolving. So if you want to continue to learn more about it and stay up to date, visit d.android.com/ml. Thank you.
Hi, welcome to our talk on Android graphics. I'm Chet Haas.
I'm Samir Kataria.
And we are on the Android graphics team, and the Android graphics team basically writes the software that gets the pixels to the screen, which involves the drawing operations, figuring out what the color values are, and it also involves a lot of work on high performance rendering. Speaking of which,
let's talk about low latency graphics. So, when you're using a pen or stylus with your Android device, you might notice that as you draw a stroke, the rendering of pixels sometimes lags behind where your stylus is on the screen. The reason this happens is because Android utilizes multi-buffered rendering. Multi-buffered rendering starts with input, which goes to the app. This is written to a buffer, and this buffer is passed around to another part of the OS. This part of the OS then actually displays it on the screen and renders out the pixels. This can take a little bit of time. There is another way to do this, and it's called front buffered rendering. Front buffered rendering has the app writing to the same buffer that the display is reading from, and this takes much less time. This is the ideal way to render for stylus input. It is possible on Android using OpenGL on almost all versions of Android. But historically, we haven't given platform support for it in our APIs until Android 13, where we added it to hardware buffers. Today, we're also introducing a Jetpack low latency library to implement this in a backwards compatible way for stylus-friendly surfaces. Please check out the talk, Adding Stylus Support for Your Android App, for more information, but I'll describe the high-level architecture here. Think of it as two different layers, one on top of the other. The top layer is front buffered and is called the active stroke layer. The bottom layer, where the rest of your app's UI is normally drawn, is multi-buffered and it's called the committed content layer. So starting with the stylus input, this all happens on the front buffered layer. We draw a stroke, still rendering it as fast as we can. And then when we lift up, it is committed to the content layer behind it. So you get the best of both worlds. You get a fast response to the stroke being drawn, and you get multi-buffered rendering behind it.
all right, so let's talk about something completely different, blurs. So you could do blurs before, but it wasn't necessarily obvious how to do that. We're making that a lot easier as of Android 12. But before we talk about blurs, let's talk about how drawing happens on Android. In general, most drawing operations, even when it's just a UI element on the screen, go through a series of primitive operations at low-level APIs like Canvas and Paint and Drawable, stuff like that. So a typical operation looks something like this, where we have a draw line command, and that has really three portions to it. One is the operation that's happening. In this case, we're drawing a line. The other is the placement of that thing. Where are we going to start and end? What is the size of this object? And then finally, what are the attributes? How are we going to draw this line? What is it actually going to look like? The attributes are collected into the paint object, which stores the information about how each object is drawn. There are simple attributes like what color am I going to draw the line, or how wide is that line going to be, or do I want to fill this rectangle versus draw an outline of the rectangle versus both. There are also more complex and interesting effects like color filter that changes the color of each pixel as it goes through the rendering system, or shader, which gives you things like linear or radial gradients or bitmaps. And that tells the system, when I draw this line or this rectangle, I'm going to sample those pixel colors from some bitmap off screen, and then I'm going to basically draw that bitmap out into the area. But each of these operations is going to be very manual. You set one of these attributes on the paint object, and then in a custom view, you're going to call one of these canvas commands to draw a line with the paint that holds this information. But what if you want all of those attributes applied to the overall view? Well, that's why we introduced the Render Effect API in Android 12. This allows you to collect all of that information together so that you don't have to have a custom view and go operation by operation through. You're just telling the view, these are the attributes that I want to apply. So to do this, you call set render effect on a view, and then you don't need to do all these things manually. There are several effects that we build into this API to begin with, things like drawing from a bitmap or color filter stuff that I mentioned before, or blending modes, and there's blur. So let's talk about blur. So first of all, I wrote this simple demo over on the right. As I drag the seek bar back and forth, you can see the blur radius is changing for both X and Y, and it tells us the area that we're going to use to get the information for each of the resulting pixels. I should point out, don't write an app like that. You don't want to seek bar and make the user pick some blurry background. But this was me playing with the effect to figure out how things worked and what the visuals are going to be like for a UI effect that we will see a little bit later, where I pop out information on top of a blurred background. So how does this work? As the seek bar gets dragged around, we get this listener called, and there we call update effect with the current value of the progress. And update effect then takes that value and says, well, if it's 0, then we're not going to set a render effect at all, and instead we're going to set render effect to null. But if it's greater than 0, it's going to be a value, in this case, from 1 to 50, then we're going to create a blur effect with the radius that results from that value, and then we're going to set the render effect on the container. It's going to blur everything inside of it.
Okay, let's talk about surface view and texture view, which are two different ways of embedding content into your app's view hierarchy. So surface view has been around since the beginning of Android. And the core concept with the surface view is that it cuts a hole through your app's view hierarchy down to a surface, and that surface is assigned a hardware overlay. You can think of this as a second window that is more power efficient and supports high dynamic range rendering. So here's visually what would be happening. You have your app surface. We literally cut a hole. We put the surface view surface underneath it so it can render through it. Texture view, on the other hand, has been available since API 14. It's meant for deep integration into the view hierarchy, so content is drawn to an off-screen buffer and copied back into the view hierarchy. And you should note that this is like an extra operation, or it takes a little bit of extra time, so it's less efficient than a surface view. So this gets to our recommendation. We think surface view is the way to go for most cases. Media content can be shown in HDR. DRM playback is only possible using a surface view. Games are already using surface view, and we recommend that they keep doing so because they control their own content generation. Texture view does have some specific use cases that it's useful for. For example, if you want to use view level primitives like rotation, alpha, render effects, clipping, etc. Also, if you need to sandwich something between two different views, a texture view is the only way to do it. As I said, a surface view cuts a hole, so it's not as possible to do it there. So, in short, use a surface view.
All right, now let's talk about AGSL, Android Graphics Shading Language, which is basically pixel shaders as of the Android 13 release. So I mentioned shaders before, and those have been in the API for many years, but those are fixed function shaders. You can pass in parameters for those kinds of shaders, the linear and radial gradient stuff. Those are essentially shaders which are altering the value of each pixel along the way, but you can't really have a lot of flexibility there. In Android 13, we give you full-on pixel shaders, which allows you to write your own code and pass in functionality and logic that is going to dynamically determine what happens to each of those pixel values. So first of all, let's talk about what pixel shaders are. I should note that the correct term for anybody that wants to correct me in this video is fragment shader. That is what people actually talk about. They're kind of the same thing, except fragment is really about the stuff that is visual, that is going to be altered on the screen, as opposed to pixels, which are every element on the screen. They're kind of synonymous. Pixel is a more common word, so I'm using it here so that it's not as confusing. Anyway, a pixel shader is the code that is going to run on every single pixel of an image to determine the final color value that shows up. All right, so here we see some simple code on the screen that shows a shader that is going to create a particular visual when it is run on every single pixel of a rendering surface. So you can think about this shader basically running on every pixel that you are seeing, resulting in this, which is a lot more interesting than the code that was on the screen before. So if you go to skia.org, you can see other examples of that shader as well as some other ones. So here you can see me clicking through the shaders on the left, and you can see the code that represents that shader on the right, and then the visuals in the middle. Some pretty interesting stuff going on here. Very graphically interesting, dynamic, custom content, which is great. But what I want to focus on today is how would you use shaders in more of a dynamic UI situation as opposed to just full-on custom graphics. That is also possible. Well, so let's see how that works. First of all, what is AGSL? As I said, it's Android Graphics Shading Language. It is basically SKSL. Full-on, it is the Skia shading language. We renamed it for Android so it'd be a little less confusing name-wise. And it's very similar to GLSL ES 1.0. So if you have written shaders in OpenGL, it's going to look really, really similar to you. The difference between GLSL and SKSL or AGSL is GLSL integrates that shader into the GPU pipeline, and that basically says, here is what that pixel or fragment value is going to be. In Skia, it is going to integrate that shader into the rest of the shaders that are operating on that fragment. It's doing things like clip bounds checking and anti-aliasing computations. All of that gets compiled into one shader that runs all of this code. So you can think of this as being injecting your shader code into the overall Skia rendering pipeline. One of the interesting things I think about shaders is that, gee, it seems like a lot of operations are happening on every pixel. Maybe I shouldn't use shaders because that sure seems like a lot of work. But the truth is we've been doing this since we enabled hardware acceleration way back in Android Honeycomb. This is how GPUs work. They run code to calculate the color values for every single pixel. The only difference here is we're allowing you to add a little bit of code and customize what that shader is doing for each pixel, as opposed to just letting the system compile its standard stuff given the other attributes that you passed in for the drawing operations. So the way that you use AGSL is basically create a runtime shader. You pass in a string, which is the code that you want it to use. It will compile that string and then it'll cache that in the system. And then you set the shader on a pane object if you're going to draw manually the drawing operations like drawing a line with a shader or whatever. Or if you want to apply it to an entire view, as I was saying before, that's what render effect is for. So you can create a render effect that uses a shader as inputs, and then apply that to a view or a render node, and it will apply to all operations that happen on that view or render node. Let's talk about what happens for a typical shader running on every pixel of an image. So first of all, we have the input color. This is the color that would be used if we didn't have this extra shader logic kicking in. That goes in through our shader program, and then out the other side comes the color that we have computed. So if we take a look at the shader code here, we have the coordinates. That is the XY location of this pixel in the overall rendering surface. Here I'm creating a static red color, and I'm going to mix that, just do a simple linear interpolation and use half red and half whatever the original color was. So if we look at that, it looks something like this. We may have had an image coming in, and now we're going to run the shader logic on it, and we're going to tint every single pixel red along the way. So if we go back to the demo that we saw before where I was just blurring the background, the reason that I was doing that was I wanted to pop something to the foreground to draw the user's attention to that picture, much like a photographer draws the user's attention to whatever's in focus, and then everything else just kind of fades into the background. So the other thing I wanted to do with this demo was to have a label that is applying additional shader logic on top of the blur that's happening in the background. So let's take a look at how that happens. You can see that where it says Ocean View Crete. That is some shader logic that's doing both a blur as well as a frosted effect on top of it. So we can take a look at the way that that works. So first of all, let's look at the containment hierarchy. So we have the overall container that is the picture gallery that has all of those views inside of it. That's the thing that gets blurred by the render effect that we saw earlier. On top of that, we have a pop-up that's coming up in the front, and that is an image view. And then on top of the image view is a text view. The text view, all that's doing is drawing the text onto a transparent background. The actual shader logic is running on the entire image view, although it's only applying to the pixels inside of that label area down at the bottom. So first of all, this is how we actually create and pass in values for the shader. First of all, we're going to set the height and width so it knows how big the rendering surface area is, and then that allows it to calculate what the label area is, where it's actually going to apply the shader logic. And it's going to create the runtime shader effect and tell it the value, the name of the variable where it's going to pass in that input color, which is input shader, and then it sets the render effect on the view. All right, here's where we actually create the runtime shader logic itself. We're passing in a string that contains all the code. You can see the variables that we have up at the top called uniforms for the width and the height of the area, as well as the input color that's coming in. We have the coordinates that are telling us the XY location of that input value. We're going to calculate that value up front. We're just going to do an eval on the chords, and that says, here's what the input value is. If we are not in the label area, we're just going to return that value. We don't want to do any shading when it's on top of the label, so then we just return current value. Otherwise, if we're in the label area, then we go on to the next step. So there's two parts to that. One is if we're inside of the label area and not on the edges, things get a little bit funny when you blur on the edges. But if we're inside the label area, then we're going to do a simple box blur. This is not as good as the render effect blur, nor is it as fast. But it shows you just a way to get a simple blur for the pixels that I want under that frosted area. It's simply going to combine the 25 pixels that surrounds the pixel where we're actually calculating a value for right now, and then average those. And then I want a frosted effect on top of that. So now I've blurred those background pixels under the label, and then I want to apply a simple gradient that's going to be opaque white at the upper left down to mostly transparent white down at the lower right. And that is going to basically expose more and more of the visual, as you see here at the top of the slide. So to do that, we have this lighten factor where we calculate what's going to happen in this linear gradient. And then again, we do a mix, which is just a linear interpolation of whatever the original pixel value was with this lightening factor that we have applied to it. And that is it.
Thank you.
Thanks.
my name is Diana, and I'm a Developer Relations Engineering Manager here at Google. Today, I'm excited to talk to you about the new version of the Play Billing system and how to migrate to the Play Billing Library version 5. So in today's talk, first we're going to introduce the new capabilities built into the system, especially for subscriptions, and then we're going to check what changes your integration may need to adopt these new capabilities. So let's talk about this new set of capabilities. The first thing you need to know is that the new version was built completely backwards compatible, so your app, your backend integration, and your current subscriptions work exactly as before. You can adopt the new capabilities gradually, so once you adopt Play Billing Library 5 and the new backend endpoints, you're ready to add them to your integration little by little. And we have introduced new ways to sell and manage your subscriptions, reducing the operational cost that is associated with the need to create and manage an ever-increasing list of SKUs. So for the new features, we have new ways of selling subscription plans, like prepaid plans. And with price change management and pricing cohorts, you're in control of when your existing subscribers get a new price, when you need to update your subscription products pricing. There's new offering capabilities, for example, pricing phases for easier, more flexible offer definition, and also easier offer eligibility control. There's another interesting addition with base plan and offer deactivation, which allows you to activate or deactivate what subscription products are available for purchase in your app. That, along with tags, gives you a flexible way of managing your subscriptions catalog without having to do many code changes when you change what's available for purchase. If you want to see more about how the new subscription configuration capabilities, you can read the Create and Manage Subscriptions article on the Play Help Center. So subscription products Google Play Billing are now represented by a hierarchy of new entities that relate with different aspects of the user's relationship to the subscription product. So subscriptions represent what you're selling to the user, the product, the benefits, and the description. Base plans are how you're selling it to the user. So it talks about whether if it's an auto-renewable plan or a prepaid plan, the billing period length, and also the base price. And offers are pricing modifications that you can apply on top of the base price. So for example, free trials or introductory prices. Developers can also establish their offer eligibility criteria. We have introduced new classes both in the Play Billing Library and the Google Play Developer API to manage these new entities. Your pre-existing subscriptions before the launch were automatically converted to these new entities. But what happened with them? Don't worry. Any existing subscriptions work exactly as before and are now represented by one subscription object with one backwards compatible base plan, and if you had enterprise or free trial, one backwards compatible offer. There can only be one combination of backwards compatible base plan and offer in each subscription. This ensures that the system knows how to translate back to the older entities used by live versions of your app. And your converted subscriptions were made read-only in the conversion process. This is just to avoid any accidental changes after the switch. And you can make them editable again from the Play console. If you do that, if you make any changes, that you're not affecting your live versions of your app in any way that can break them. It might be simpler to create new subscription for the new versions of your app that we're going to build with Play Billing Library 5. And to read more about how to configure your subscriptions catalog for this new system, you can read the documentation that is referenced there at the bottom. Okay, so now that we have seen the new features that we released and the state of your subscriptions catalog right after the conversion, we will discuss how to gradually move to the new model. Google Play Billing integrations talk to the Play backend via the Play Billing library from the Android app and the Google Play Developer API from the developer backend. This developer backend component is essential to manage the subscription entitlements correctly and efficiently. For this migration, you're going to have to modify probably both. While you don't need to migrate immediately for your integration to work as it used to work before May, we recommend developers try to stay in the newest version possible. Each Playbill library version has a lifespan of 2 years from the moment it gets released. This year, we deprecated Playbill Library 3. Migrating your app from Playbill Library 3 to Playbill Library 5, it's very similar to start from Playbill Library 4. It also gives you the additional benefits of the new capabilities and a little extra time before your next required migration. So I'm going to mention the Google Play Developer API several times in this talk. In particular, I will be referring to the component of it called the Subscriptions and In-App Purchases API, built to manage in-app purchases from your app. Okay, so the new backend API includes a new set of endpoints to manage your subscriptions catalog programmatically, all of them under monetization.subscriptions. It also includes a new pricing conversion endpoint that allows you to translate any price to all the supported regions and currencies on Google Play. And there's a new endpoint as well to manage your subscription purchase status. Developers may handle their product catalog programmatically in addition or instead of using the Play console. If you do this, you're going to want to look at these changes because the moment you make your subscriptions editable on Play console, the old endpoint won't work for them. So if you now use in-app products for managing your subscriptions catalog, you should start using monetization subscriptions. The new endpoint uses create instead of insert, patch for all updates, and it introduced the capability to archive a subscription. The in-app products endpoint is still there and still works for one-time purchase products. And you could also use it while your existing subscriptions that were converted are not made editable for your subscriptions. So the new resources adopt the same hierarchical structure that we talked about with the entities. So we have subscriptions with several base plans and potentially several offers under them. To see how these new resources map to the old in-app product resource, please check the compatibility guide on the documentation under the title May 2022 Subscription Changes Guide. So now that you have learned how to configure your subscriptions catalog in the new model, let's see how to change your app to sell these new products. We are going to follow the steps in the Google Play Billing Library 4 to 5 migration guide, which is in the Android developer documentation site. The first step is upgrading the dependency of your app to the Play Billing library to the latest version. You do this on your build.gradle file. The latest version is 5.1 right now. If you started your migration from Play Billing Library 4, your app will probably build right away. If you started with 3, some methods may have been deprecated since then. To check out what methods were deprecated in each version, you can look at the release notes page. So the first step now is the initialization of the billing client, and it has not changed since the previous version. You will still call new builder to create the client, and you will set a listener to purchases update listener. These will be called every time there's new purchases in your app. After you initialize the billing client, you will establish a connection with Google Play, just like you did before. This is the same start connection call, and you will implement a couple of callbacks on billing setup finished for successful connections, and on billing service disconnected to let you know when the billing client has lost the connection. It's really important that the connection is in a healthy state before you enter any user critical flows. So now that the connection is established, it's time to get the products available for purchase from Google Play. There are changes in this step, so your app can support the new product types. So query SKU details async is a deprecated method in Play Billing Library 5. It's still present for backwards compatible reasons, but you're going to have to switch this call. We have created new classes to replace SKU details params and SKU details as well. So now you will use query product details async, and to build the parameters for this one, you will provide a list of query product details params. Each of these contains the product ID of the product you're trying to retrieve and the product type. These are all new classes. Once you call query product details async, the callback will return a list of product details. Each product details item contains the information about the product, so the subscription, the ID, the title, the type, and so on. An important difference with this new system is that each product, in particular subscription product, contains a list of subscription offer details. This object contains all the different ways a user can acquire this product. If the user is not eligible for a particular offer, it won't be returned at this step. So that's how the system handles a predefined eligibility. So for example, if a base plan doesn't have any special offers under it, or the user is not eligible to any of the special offers under a base plan, you will only get one element in this list. It's one offer with only one pricing phase containing the base price. The subscriptions offers detail object contains some details about the offers that will help you decide how and when to display it and how to sell it. So, for example, get offer token returns the offer token needed to launch the purchase of this specific offer. And the pricing phases will return the different prices that the user will get along their subscription journey. So you can correctly display the product. All right, so developers can decide which offers will be surfaced in the app and how. Offer tags, in particular, offers you a new tool to categorize your offers and decide how this happens. In this example, you can see the developer has created a tag called loyalty 1 year, and he uses it to decide which offer should be displayed to a user that qualifies to a special loyalty program. So if the user meets the developer criteria and the offer is available to them, the app is able to display it. The nice thing about using offer tags for this is that if the developer wants to change what offer the users in this program apply to, they only have to move that label to a different offer, and the app will continue working exactly as before with the new offer without having to change the code. So it makes it a little bit more manageable. All right, so let's say the user already selected which offer they want to buy. It's time to launch the billing flow. Okay, the billing flow params set SKU details method has been deprecated. Let's see how to specify the product that user wants to acquire. So for each product that will be bought, create a product details params object that contains the product details object that we talked about before and the offer token that indicates the exact offer you're going to sell the user. This is a string value. And that billing flow params goes into the, so that list of product details params goes into the billing flow params and is used with the method launch billing flow. Just as before, you'll also specify a reference to an activity from which the billing flow will be launched. And so, after the user goes through the billing flow, it's time to handle the outcome. This step is very similar as before. The only small change is on how you pull new active purchases. So since the SKU type is deprecated, you will call query purchases async now with a query purchases params object. And in this object, you have now a set product type method to take this equivalent step to indicate what kinds of purchases you're pulling. There's a new enum product types that lets you indicate whether they are subs or in-app products. And these are the main changes in your Playbill Library 5 integration. After making these changes, your app is ready to leverage the new features in the Google Play subscriptions platform. All right, so once your app is migrated, your backend needs to start handling purchases made with these new methods. The subscription status management component in your backend uses the subscription purchases API. Let's see how to change this component to handle these new types of purchases. All right, with real-time developer notifications, developers get a message every time a purchase state changes. And with that information, they're able to call the Google Play Developer API to pull the purchase status and adjust the entitlement accordingly. This remains the same. The difference in this new version is that the endpoint you're going to use to pull that subscription status is a different one. It's called purchases.subscriptions v2, and it only has one method, get. This new get method returns a new set of resources with the purchase status. The old endpoint purchases subscription is still there, and all the other developer lifecycle management actions, such as acknowledging a subscription or canceling it, are still in the old endpoint, so you will still use it. The old get function in that old endpoint only works for purchases made with all methods of the playbilling library. So it's not going to be valid if you're already selling new types of subscriptions in your app. All right, and these are the new entities. The subscriptions purchase V2 one contains information about the line items or the different products acquired in this purchase. Each of them is a subscription purchase line item, and you can see how you can obtain things like the base plan that the user acquired or the offer details. To see more about how these entities map to the old one, you can check our May 2022 new subscription features guide on the developer documentation. All right, so this is an example JSON of what you would obtain after calling the subscription purchases status API. And as you can see, pretty simple. So thank you for your attention today. I hope this presentation helps you plan your migration to the new version of the playbilling library. For more information, always check out our developer documentation. Cheers.
Hello, I'm Todd Berner, and I'm on the Android Developer Relations team here at Google, and I focus on security. The motivation of these next few minutes is to help clarify a concept that's becoming more and more essential to modern app security: attestation. The truth is that Android's basic frameworks provide a deep level of security for your app, but there's likely cases in your app where it interacts with sensitive data or your backend that you need to be sure that you're talking to the device and user you think you are. The word exploit means dramatically different things when we consider different types of apps. Exploits generally fall into two categories: an outside entity attempting to attack your app and harm your users, or sometimes it's individuals who are acting in bad faith when interacting with your application. If you're a game developer, maybe it means someone cheating to get the highest possible score, or maybe even impossible score. For streaming apps, it might mean piracy. If you're a financial app, it could be effects to your customers' bank accounts, or if you're an enterprise yourself, it could be access to your systems. As Android security has increased, attackers are looking for new ways to compromise the device. And while we as developers build and test our apps and continue to fix any sorts of issues we see in the field, there are still things we cannot control. In fact, your app isn't always your app. Many apps depend on only a properly structured request against their backend to access information. And this means a repackaged version of your app could allow a user to make requests that you aren't inspecting. This could enable users to take actions like updating their high score in a game or breaking any other client-level logic or validation that you might have put in place. In this chart, it shows that while the backend is seeing a request that looks the same, it's actually run from all three: a genuine GMS Android device, an Android emulator, and even a Python script. When you form an API request, it all comes to the app or game server looking identical. While this might seem okay, this could allow nefarious actors to access the APIs when they shouldn't be able to. This could mean your entire client-side validation might not serve as any protection. In addition, your app isn't alone. Your app runs on a device with many other apps, with an operating system, with a user. How do you know you can trust each of these? A user's device could be vulnerable because of not having the most recent security patches, or they could be running Android within a container to control other elements of the environment. Instead of asking, do I trust my app, or do I trust this request against my backend, trust in your app is more complicated. You must ask, do I trust each and every part of this picture? The firmware, the OS, the application, the device, and the user. We call this layers of trust. As an app developer, this might be daunting. It looks like you need to keep track of whether or not you can trust each firmware, each OS, each device, and even each chip on each device. Apps might be where the users and developers interact, but if we don't consider these other interactions, we leave ourselves vulnerable to various possibilities for exploit. Device attestation allows developers to learn about the security of devices' current environment. It should be used each time a device requests access to potentially sensitive information. The attestation response helps developers decide how risky it would be to access the information. Within Android, the Key Attestation API is an anti-abuse API that allows developers to assess the Android device their app is running on. The API should be used as part of your abuse detection system to help determine whether your servers are interacting with your genuine app running on a genuine Android device. You should think of this as a full description of the environment that your app is running in that you can see before you allow the user to take action. This helps developers assess the boot time integrity specifically and determine if the Android security model is being enforced as expected based on the boot time properties of the attestation report. It helps answer questions like, is the correct version of my application running on the device? Did the device boot into genuine software? If I'm using encryption keys, where are they stored? You can then take this information and decide whether or not to let the user take action. From there, you take action to allow or block the user from taking action based on the returned information. The functionality of attestation itself will not make the decision for you. It's crucial for you to think of the impact of allowing users to take action and what the alternative is. Not all devices will have the most recent security patch, or you might not support advanced features like Strongbox, and you as the developer must decide how to navigate based on the responses and the nature of the access the user is requesting. AOSP provides the building blocks to implement a system of attestation through a functionality called key attestation. This provides a response with all non-privacy compromising boot time integrity information that could be relevant to Android developers. Google Play has built on top of this to help developers detect risky interactions through a tool called Play Integrity API to prevent abuse and attacks. Key attestation is a technology that's built into AOSP, and it provides a way to strongly determine if an asymmetric key pair is hardware backed. It shows the boot time properties of the device at the time the key was created, the properties of the key, and what constraints are applied to its usage. While it was built for the general case of binding attestation to hardware and firmware signals, its use case as an integrity monitor makes it a great foundation for the Play Integrity API to build on top of. It returns almost 50 pieces of information in its schema and surfaces detailed information and includes attestation information on the newest security features. An example is seeing if it is being run in software, hardware on the device, or a certified vault called the Strongbox. This might make you feel like you're superpowered as a developer, knowing exactly what's going on a user's device. This information might seem essential to you as you want the utmost security for your app, but you run into the question of what decisions should be made based on the information. How large of a decision tree are you going to implement? As you can imagine, the complexity becomes quite extreme. Google has offered a more simple way than key attestation for Android. Google released Safety Net Attestation API for Android apps in 2016. It specifically checks whether a device is a certified device that passes the compatibility testing suite, whether it's rooted, or if the device doesn't register due to factors such as a protocol emulating script. Our discussion today is well-timed because new apps can no longer use Safety Net for attestation, and Safety Net will be fully sunset in the near future and is being replaced by the Play Integrity API. The best option for attestation in Android is the Play Integrity API. When your app or game is used on a device that runs Android 4.4 API level 19 or higher, the Play Integrity API provides a signed and encrypted response that checks the environment for the following information. Genuine app binary, determining whether you're interacting with an unmodified binary that Google Play recognizes. Genuine Play install, showing whether the current user account is licensed, which means that the user installed the app through Google Play. And genuine Android device, detailing if your app is running on a genuine Android device powered by Google Play services. Play Integrity API returns approximately 5 values, 2 of which lead to clearly understandable decisions. App integrity is powered entirely by Google Play and checks if the app is recognized and the certificate matches Google Play's records. It can have results of Play recognized, unrecognized version, or unevaluated. Play Integrity API also has a device integrity verdict related to attestation. Here you can see the device integrity result is meets attestation. Meets device integrity, meaning the app is running on an Android device powered by Google Play services. The device passes system integrity checks and meets Android compatibility requirements. If you opt in, you can also see meets strong integrity, which is powered by key attestation directly. This means the app is running on an Android device powered by Google Play services and has a strong guarantee of system integrity, such as hardware-backed proof of boot integrity. The device also passes system integrity checks and meets Android's compatibility requirements. Other possible results for emulators or unlocked devices are meets basic integrity or meets virtual integrity. Play Integrity's API simplifies the response, and this allows you as the developer to focus on your larger responsibility of preventing access to your service based on the results. You can see whether the app is being run on a device that is the same version of the app that's available on Play, and you can also confirm that the device is a real Android device. From this information, you might decrease service performance, add a reCAPTCHA, or entirely block a user from your service or app. The work to handle the response is essential, and because your team will need to take this on, it's important to simplify. And in our view, the best way is taking the verdict-driven Play Integrity API responses and make decisions in your app from there. We recommend implementing Play Integrity API rather than key attestation directly, because implementing attestation is only half the battle. While it might also be nice if you could simply block all the devices that don't pass every part of every check from using your app entirely, it's actually better to identify where in your app device security is essential and find ways to implement the API and handle the responses in those locations. Thinking about how to handle responses is essential, but it's hard unless you put it into the context of your app. To help, let's explore how device attestation provides insights into 2 problem sets that many apps face: access and trust. Many apps serve as front ends, and they heavily depend on authentication to provide access to sensitive data on a web-based backend. When accessing data, the users of the app might provide the right username and password, or might even have the right certificate installed on their device. But we can't make assumptions about the rest of the device environment. Otherwise, we leave ourselves open to several other methods of exploit. The earliest adopters of mobile device attestation were enterprises, requiring certain device standards for compliance or information security, especially when their employees bring their own devices. By using attestation, the enterprise's IT department gets to decide what conditions a device must pass before access is granted. We've seen adoption in financial apps as well. These apps check if their servers are interacting with a genuine app running on a genuine Android device, ensuring a more predictable environment. This makes it more difficult for a hacker to use a clone or substitute app to connect to the financial institution's servers. As apps get larger and more popular, they become exposed to users who try to exploit their apps or services. For example, we've all tried to investigate a bug report or strange server interaction, only to find it was due to a rooted device. Because you can't always trust the rules you've created in your code, you also need to verify that you trust the user themselves. Attestation provides an easy way to get context, and we've seen it used to ensure trust in many ways. In games, it's commonly used as part of anti-cheat software to detect possible cheats and vulnerabilities within the device's memory and processes. Attestation gives messaging apps additional security, as it can prevent third-party use of your APIs trying to pose as a fake app. In this case, attestation is used to ensure the device passes Google's compatibility and integrity checks, and any device that fails is prevented from logging in. Users can try and get around your monetization as well, and streaming apps frequently respond to attestation failure by falling back to lower quality to reduce abuse of their expensive services. Any app that deals with payment portals, collects sensitive information, or needs a secure connection to servers should consider using attestation to assess the Android device requesting or sending the information. The use cases we just discussed could all be solved by the Play Integrity API, and it's important to investigate how it could benefit your app's security. The Play Integrity API protects your apps and games from potentially risky and fraudulent interactions, allowing you to respond with appropriate actions to reduce attacks and abuse such as fraud, cheating, and unauthorized access. Our docs provide an easy way to get started with Play Integrity API, and if you're a current user of SafetyNet, you should follow the instructions to migrate your app to Play Integrity API. You'll find that implementing Play Integrity API is quite similar to how you've built your SafetyNet API solution. For advanced use cases, look at our docs on Key Attestation, which provide the full schema and more. We want to encourage you to always remember to design with security in mind and use our docs, guides, and code labs to improve your apps. Thanks, and happy coding.
Good afternoon. So first I'd like to start by getting a show of hands. So who here uses Bluetooth headphones to make a call? Okay, pretty much everyone. Who here notices that when you're listening to music or basically watching your favorite movies and then you accept a call or you join a conference call and your audio quality kind of drops and there's a big difference? Good, okay, we do see some people here. So today we're going to talk about how we can use low energy audio and how this can improve the quality of your calling applications. So my name is Luke, I'm a developer relations engineer here at Google. So in Android 13 comes support for Bluetooth for low energy audio hearable devices. This means a lot of the APIs we're looking at today are available for you to start using from today. LE Audio brings huge advancements to Bluetooth, providing users with great battery performance and high-quality streaming. I think as an engineering team here, we know you don't normally get both of those things together. So you don't normally get battery life and performance. So what we're finding is that you can stream up to 32 kilohertz for media and phone calls, both for input and output. So no longer will the quality of your calls drop when you're using BLE Audio headphones. LE Audio does support multi-stream audio. This means it's capable of streaming multiple, independent, and synchronized audio streams. So a quick scenario I want us all to picture here is there's nothing here that's actually going on in real. But really what I want to do is demonstrate some of the possibilities that we could have with this technology. So all of us here, I want us to imagine we're at an airport right now, and we're sitting down, we're in a nice little bubble, we're listening to our music, we're watching our favorite movies, we're at the gate, and we're generally waiting to board. What we could do is we could connect to a broadcast at your gate, and you could continually listen to your music, and then from there you could have the audio broadcasted to your hearable device. This kind of means you don't have to take your headphones off, kind of listen for your gate number to be called, whether you're being called. So there's some really unique and interesting use cases that could come from this technology. So we're really looking forward to talking about this a lot more in the future. So the LE Audio stack is in Android 13, and it officially supports the Bluetooth 5.3, and it comes with the default LC3 audio codec. This essentially means that the LC3 audio codec replaces media and the codecs for hands-free profile calls. So this codec's much more efficient, it's reconfigurable, and it produces a higher quality of audio for your applications. For a lot of you that don't want to kind of look at codecs and get involved with that, know that this stuff's kind of all done for you under the hood. It's on by default, so you don't have to worry about a lot of these codec requirements, as it's on by default for media and calls. So LE Audio also does come with huge improvements and new standards for hearing aids too. So it offers better experiences for users with hearing impairments, and as someone that's hard of hearing myself and has to wear hearing aids on a day-to-day basis, it's really good to see kind of these new accessibility needs coming with this technology. So the hearing aid profile offers support for microphone during calls, and it does have separate channels for left and right audio. So this hands-free profile is kind of the new standard, which really aims to improve the quality and the feature set for hearing aid devices. I know for people that normally have accessibility issues and kind of need new technology, it's really good to see kind of these consumer level features coming to people with accessibility needs. So it's really good to see how this is going to drive forward going forward in the future. LE Audio does come with two paths to consider when using microphones. So one being recording mode and the second being communication mode. So recording mode offers high quality, large audio buffers, and multi-channel support for left and right microphones, whilst communication mode offers low latency and is the best experience you really want for your dialer or your VoIP calling applications. So now you'll know a lot more about LE Audio. I'm sure you want to know how to implement it in your applications. So there's essentially two ways you can implement it into your calling applications today, and that's the Audio Manager and the Telecom API. So the Audio Manager offers a way for you to choose what you want to stream to. However, it does come with a lot of overheads, as you have to deal with Bluetooth timeouts, state management, disconnection, and connection events. So there's a lot of state management you need to do in your applications when looking at the Audio Manager. The Telecom Manager, on the other hand, does offer you a much more complete API for your VoIP application needs. It's an easy-to-use API, which allows you to switch the audio routing for hearables, and it does come with a more complete feature set for VoIP applications, such as being able to hold the current call, or it does inform the platform that there's currently an active going call. So let's say you're in a conference call right now, and then you get an incoming call in your dialer application. By using this API, you're informing the platform that you're currently in a conference call with your VoIP application. So today we're going to look at the Telecom API, just due to its rich feature set and kind of the needs it has there for LE Audio. So when writing a VoIP application or a dialer application, we always have this notion of you're joining a call, you're accepting a call, maybe you're joining a conference call, and you always have this notion that there's something happening in the background. So you want a foreground or a background service to deal with the connection of the call, just in case someone needs to be browsing on their browser and they need to open up a different application whilst you're on a call. You always want this notion of having a foreground or background service when you're writing these applications. The Telecom Manager here does come with this, where it's a foreground service, and it will have methods for incoming and outgoing calls. So the Telecom service is a foreground service, which is bound to your connection service, and has methods for these incoming and outgoing calls. And once it's activated, so once it's instantiated, inside here you'll have audio-related methods. So this one we can see here is you can get a list of all the Bluetooth devices, and from here you can choose which Bluetooth device you wish to connect to. Next, we have a method where you might have certain scenarios where you might lose connection, the user might unplug their headset, they might use Bluetooth connection to their hearable devices. So we have this on-state changed here, which basically informs you of whenever the audio device is changed and really informs you of what the current audio device is that's being used by the platform. Next, users may wish to change between Bluetooth devices, wired headphones, or the speaker. So we have a simple method called setAudioRoute in the connection class, and this will correctly set up the device's routing state if you wish to change between speaker, headsets, or Bluetooth. So this is the method you really want to be using for setting between different devices. And next, we have another simple method here, which is called request Bluetooth audio. So if you're using API 28 or higher, when you request for Bluetooth audio to a specific device, you won't have to set the audio routing paths either, as this is kind of done for you under the hood. So with these few lines of code, you can quickly change between Bluetooth devices and audio states using the Telecom API, which means that you can focus more on your application rather than dealing with audio states, connected devices, timeout, and all these events we were talking about earlier. LE Audio does have the requirement for both the Surface and the hearable device to both support LE Audio. So another benefit for the Telecom API is you don't have to worry about this, as it's kind of dealt for you all under the hood. But if you do need to check if the hardware supports LE Audio, you can use the API, is LE Audio supported, in the Bluetooth adapter. For a more detailed guide on how to implement the Telecom API, do audio recording or general information on LE Audio, you can find more information on our developer website. We expect to see a lot more LE Audio devices on the market next year, and we look forward to your applications supporting these new hearables. I'd like to thank everyone for your time today, and thank you.
Hi there, my name is Marcel. I'm a developer relations engineer at Google, focused on helping build beautiful and modern widgets for everyone on Android. Today, I would like to share what makes a modern Android app widget, why it is important, and how you can achieve it with few top tips. Android app widgets have been in our platform since the very beginning. They live in the user home screen, and they are a major player for a great user experience that leads to an increase in user retention and engagement. The home screen has always been a competitive place to be. This is even more the case since we launched Material You, which has led to users expecting a more personalized experience aligned with the look and feel on their devices. By following the principles I'm about to present, you can increase your app chances of being placed in the user home screen and also provide the desired user experience. So when we refer to modern Android app widgets, here's what we mean. These widgets are aligned with the device theme. They adapt to multiple sizes and screens, and they are easy to discover. They also enable some user customization, and of course, they are helpful. But why, after all this time, would you invest again on providing a new widget experience? Let's take a look at two great examples, Google Keep and Google Drive. If these apps hadn't modernized their widgets on Android 12 home screen would have looked a bit different. They wouldn't have been aligned with the device theme, thereby ignoring users' investment into their device personalization. They wouldn't have adapted to the available space, leaving visual gaps or unaligned widgets. They would have had tiny clickable targets, causing some poor accessibility. Some users might have kept such widgets, but most would have removed them, or even worse, found other solutions. Instead, teams working on this and other Google apps refactor their widgets to let users adapt to the home screen, creating a more flexible shapes and sizes and do even more with their widgets. For example, Google Keep not only adapts to the user home screen, but also brings more value by providing more expressive shapes to maximize the space and extend the functionality. This is a much better user experience compared to the static color widget that isn't optimized for large screens. Similar to Google Drive, our team totally reinvented the existing semi-transparent and static widget. First, they leaned into the dynamic color theme. Then they optimized the amount of glanceable information based on the available size. For example, by providing a new search functionality for larger vertical spaces. So instead of seeing widgets that are outdated and stale, now users can enjoy an experience that is more personalized and dynamic. And what's more important, the teams did not only improve widgets for regular fonts, they made sure to provide adaptive sizes for tablets with larger fonts and additional actions, making sure to use that extra large space. So how can you do the same? Whether you want to update your existing widget or you would like to build a new one, we recommend following these principles. The best place to begin is with our developer resources. We recommend starting with our refresh guidance and our new sample. And even though it's currently in alpha, it's worth checking out the new Jetpack Lens library, which we have built with these exact principles in mind to help you build better widgets with compose-style code. Here are a few top tips for each of these principles that might help you modernize your widgets. When we refer to a widget that is aligned, we mean this. It fits into the shared ecosystem that makes up the home screen by adapting to the wallpaper colors and the available size defined by the system theme. It provides also a smooth launch experience for your application. And here's how you can do that. First, make sure that the layout that defines the background uses the Android ID background as ID. This helps the launcher identify better the background of your widget, improving the launch experience. Then, use the theme from the Material Components library to define the color schemes of your widget. This enables dynamic colors, but make sure to set the color resources and not the resolve color. Otherwise, the system will be unable to dynamically resolve the colors. And starting in Android 12, the system automatically applies rounded corners. To ensure your content adapts properly, use the system values in your views. To enable widgets that are adaptable, Make sure to use the available space by filling its content and adapting based on user preference. At the same time, it's important to define your widget limits. Remember, in the end, we want helpful widgets. For example, here is the system battery widget that adapts to the available space, showing more or less information about the connected device based on that. In short, make sure your widget layout fills the space by setting match parent and ensuring the rest of the content adapt. But be sure to define your limits. Sometimes a small widget does not make sense. Now, starting on Android 12, we can provide responsive layout. You can use the extensions provided in the new Android X Core remote views to simplify that. For example, here the weather widget provides 3 types of sizes. Then the launcher decides which of these fits better based on the available space. We need as well to help users discover your widget. You can do that by providing accurate and rich previews with proper labels and description that will be shown on the widget picker. Also, recommend the widget inside your application, help the user pin it into the home screen. Did you know that you can as well have Google Assistant reply to a voice query with a widget? You can check these docs for more. Adding a name to your widget is easy. Add the label to your receiver. And then, make sure to provide the description in the widget metadata. To make widgets more discoverable, provide an in-app experience and request the App Widget Manager to pin the widget. For example, after a user saved the new weather place, we could show a tooltip to recommend them to add the widget on the home screen. So having the system to request them, and you will be able to provide actually a custom preview to this screen. Every user is different, with their own individual needs. In addition to provide different sizes, it's important to enable customization when it's possible. Use the configuration screen mechanism for that, but also make sure to provide good defaults for the vast majority of users, so maybe skipping the configuration at the first time. Whatever the case, it's a good idea to let the user reconfigure it as they want. To enable this, you can set the configuration activity on the widget metadata, and then set the reconfigurable and configuration optional flags to enable the rest. Finally, widgets should be helpful. Don't overcrowd them. Make sure you provide essential information and quick, simple actions based on the available space and redirect users to the in-app experience for a full set of features. Also, and this is important, be respectful of the system health, since widgets live in the host process. Make sure to optimize them and reduce any background work by using Work Manager with proper parameters and respecting the update frequency limits. Thank you so much for watching. We hope these principles and tips help you adjust or build new, modern, and beautiful widgets that adapt to your user needs and are helpful to them, bringing more engagement and functionality to your application. Goodbye.
All right, hello, welcome back. This is the hashtag Ask Android panel. And the reason why it's called hashtag Ask Android is you can actually live tweet your questions to us and they will be answered by this illustrious panel, which includes software engineers and product managers and a bunch of developer relations people and people who are really, really doing the core work to make Android what it is today around the platform. And so we're going to start taking your questions right now. And again, just keep live tweeting them and let's go. So first question is about media permissions. We've moved to granular media permissions in Android 13, but we also added this whole photo picker thing. You know, what should people be doing?
Always fun life. Yeah, so I think, I think everyone's seen for us that storage is something that we really care about and want to make sure that, people give just the right amount of information to apps and just no more than they have to. And it's been a journey, right? We've seen scope storage, we've seen us split up the audio and the photos permission. And Photo Picker is the next tool in the toolbox for people to do that, because we truly do believe that if you are trying to select a single picture or you're trying to do, something that's very granular in scope, we want to give people that choice. And so we also want to add more functionality and want to do that in a privacy safe way. And so Photo Picker is our solution to that. So we want to make sure that you can safely choose a smaller subset of pictures, while also we're going to add more functionality like things like cloud picking as well that we are really excited about too. So just keep that in mind as you're developing things. Think about what users expect. Ask for only what you need, and as long as you do that, you'll be in line with our strategy, which is really focusing on minimal kind of scope for what you want to actually do. Anything to add, Dan?
Yeah, just to add a little on the cloud filling stuff. The storage permission has never given you access to cloud photos, and it's kind of been something that's been long. How to access cloud photos has been a long-standing kind of desire, and we've talked through it a number of times. And it's just having you say, hey, give me access to photos, and they get all the photos on the device plus all the cloud photos is kind of a privacy nightmare. So the photo picker is a really nice way for us to actually give access to cloud photos now in a way that's privacy preserving.
Thank you. All right, so a question from Twitter is, actually this is from YouTube, excuse me. Does Media 3 deprecate Media Player?
No, it does not. Media Player is a platform API that ultimately Media 3 also uses under the hood. So no, they'll continue to exist, but Media 3 just handles kind of a lot of that fragmentation for you, and hopefully makes it easier to develop better media apps.
All right, so what's the best way to think about accessibility if I'm building an app, let's say in Compose?
Yeah, so I think the best time to start thinking about it is at the beginning. So hopefully you're thinking about accessibility starting from the design phase. There are some APIs that were available in the Vue system to do with accessibility that doesn't exist in Compose, but if you find a use case that you think an API would help with support that, feel free to file an issue in our issue tracker. Some other things we're currently working on is making sure the tools in Android Studio and testing tools for accessibility work better along with Compose as well.
And how do I decide whether I'm using ML-Kit or a custom ML stack?
I think that's a question for me.
Yeah, sorry, I'm not.
So in the talk, I touched on that a little bit. It really depends on your machine learning experience. So if you have expertise and you know how to build a model, how to optimize it, then you probably want to build your custom model and use TensorFlow Lite, especially get it through Google Play Services. But if you don't know machine learning very well and you still want to benefit from some of the use cases, and it can be many things like selfie segmentation, object detection, ML-Kit is really, really nice, very easy to integrate. All the APIs are in Kotlin, so if you are an Android developer, it's pretty straightforward to integrate that in your application.
So one question another question for the panel here is about media session. How can we test media session appropriately to make sure it's been implemented correctly?
Good question. Hopefully, in my talk, as I demonstrated, media session can be fairly complex, so I'm glad that people are thinking about testing. I'll call out two tools. One, I would highly encourage you to make use of the emulators that we have in Android Studio. From personal experience, I know that it's difficult to say buy a car. So if you want to test for Android Auto, I highly recommend that you use the emulators we have available. They should be, very similar to what the IRL experience would be. And if you find any sort of differences, please let us know so we can kind of fix that. The other tool that I'll call out is the Media Controller Test app available on GitHub. It's a super great tool that is basically an open source implementation of a media controller so that you can test kind of your media session, media controller interactions in a more controlled environment.
So AGSL shaders are pretty cool. Is there any way we can get them in Android X?
No. So this is one of those awkward bits of new APIs, new functionality that we add where it depends on capabilities below that layer on the platform itself. In this case, it depended on some changes and enhancements and new APIs at the Skia native as well as higher level APIs. So that really needed to be a platform change that people can adopt as their users get to those platforms. I should point out, though, that it's a little confusing because we call it shaders, but we already had an API that called shaders, right? Since I think 1.0. And they are kind of the same thing. It's just one is programmable. Like AGSL, you can do whatever you want. That is logic that will run on every pixel, on every fragment, doing whatever you want to do with that pixel and color value. We have shaders already. That's why they're also called shaders in 1.0, but they are parameterized, so you can get a linear gradient. You can get different kinds of gradients or different bitmap or color operations. A little more basic, but still sort of the capability to vary per pixel the value that's coming out the other end. So you go ahead and use those. You don't need Android X. They've been on the platform forever. And AGSL adopt when it makes sense.
So, all right, my notifications are delayed. Is Android doing anything about it?
I get this one. I'll quote Tim Cook and say, get a Pixel device, I guess, would be one answer. So Pixel, hopefully we're talking about not on Pixel. I mean, I think that there's there could be a lot of things going on. There's certainly, you should be using FCM. I think our general delivery is good on FCM. There are OEMs who do various things. We've been working with them for a number of years now. Sadly, I don't have any really good news at this point to report. But yeah, we're aware that the OEM customizations are becoming an increasing problem that is causing a lot of trouble for our developers, and we definitely want to improve that.
Yeah, another related question is, what is the best way to run background work reliably across the ecosystem?
Job Scheduler is definitely for background work. Job Scheduler is the right thing to do, and it's and Work Manager. Usually, you use Work Manager. That'll use Job Scheduler underneath, and that is that's definitely a recommended way to do, and that's what all the Google apps use. So it's definitely the widely used thing.
So another question, this isn't related to this at all. Is there any plan to make use of Media 3/Exoplayer easier with Compose?
Good question, and glad to hear that we have more interest in using Compose. It's a feature request that we are aware of, but I don't have anything to announce at the moment. I highly encourage you to head to our GitHub, the Android X Media GitHub, and file a feature request there just to kind of express your interest, and we'll hopefully have better news to share soon.
And speaking of that, we added performance classes, recently, fairly recently in Android. Can the performance class of a device change? And these are mostly around media performance classes.
Yes. To clarify, performance class is assigned to kind of a combination of a device and the build that it's running. So let's say, for example, you have an Android 12 device that is performance class level 12. When it updates to Android 13, if it meets all of the requirements for performance class 13, it'll get upgraded to that higher performance class level.
So kind of changing topics again. When we're talking about predictive back is kind of a big new thing that we sort of quietly introduced in Android 13. What kind of strategy would you have for migrating to your apps using predictive back?
I guess it's just me. Yes, so predictive back is a multi-year strategy to try and give developers time to understand this shift to this ahead of time model that I mentioned in the talk. So in Android 13, we have already released an update to the Android X library at 1.6. So I would strongly recommend, first of all, using the Android X library, because that way you're going to get a lot of the features out of the box for free. If you don't intercept the back gesture, which many apps actually don't, then the migration strategy for you is primarily add the flag in your manifest, test how your app works, particularly in just the back to home is where you're going to see that animation in Android 13. And also the user right now is behind a developer option. So it's a pretty safe way that we launched predictive back. And Android 14, obviously, we're going to be releasing more features and doubling down on that back gesture to have not only the back to home piece, but within app, you're going to see that predictive piece. So my recommendation would be Android X library for sure, testing, but also there are many checks that are going to happen to ensure that your app behaves nicely.
So this one's interesting. Can app shortcuts be enrolled for Android 13's dynamic icon theming? Anyone? We'll get back to you on that one. Not everyone knows everything, as it turns out. Okay, so another question is, we talked a bunch about Camera 2 today, and we also have, of course, Camera X. And where should someone be looking to target Camera 2 versus Camera X?
Yes. So the first thing is that Camera 2 is part of the platform, which we update yearly, right? So Android 13, Android 14, 15, and so on forth. Camera X is built on top of Camera 2, and it's Google's Jetpack library that allows you to, that makes it a lot easier, right? It handles a lot of the things like fragmentation and a lot of things that you would have to kind of deal with yourself if you go into Camera 2. So what we kind of recommend, Google's we start with Camera X first. Start with the Jetpack library. It'll handle a lot of things and handle most of the simple use cases, like take an image, simple video. If you want to get deeper than that, if you want to do things like most social media apps will be doing today, kind of control the camera system frame rates, all these different things, I would then start to say, okay, start to investigate Camera 2 a little deeply and start to integrate there. The thing is, I think there's a perception that Camera X is just not as powerful as Camera 2, which is not true. We're kind of trying to shift this combative, more so, it's Camera 2 versus Camera X, to a more Camera X and Camera 2 model, where it's you start off with Camera X. If you need more, then start to investigate deeper into Camera 2. And we're working on not only providing more resources on making Camera 2 a lot easier to understand and develop for, but as well as get developers more, I guess you can say, less afraid of Camera 2 and how a little bit complex it can be sometimes.
If I can add to that too, I'm going to jump in. I was talking to the Camera X team a couple of years ago about this exact issue, and the way they viewed their API and their functionality was more use case driven. So as you said, the easier path and the frankly very powerful path is to use Camera X. But if you find that your use case goes out of the specific ones that Camera X provides, that's sort of where you may dip into the platform APIs more directly, right? So it doesn't necessarily do everything that Camera 2 does by design. Instead, it should do most of what you need in a much easier way.
Exactly.
So, and one of the other questions that came in, with so many manufacturers doing all these different things on their devices, how can we as Google enhance the photo experience in social media across the board?
Interesting question. I think that one of the things that we are trying to do, and this is why we're taking a lot of developer feedback now. Like, obviously, with every platform release, we take in as much as we can ahead of time and focus on those issues. Like, a lot of the things that we've put into Android 13 are things that were directly asked by developers for the functionality that they wanted for the newer versions and moving on. I think that, improving photo quality across the board, we're trying to see, like, maybe at some point, I can't announce anything yet, nothing's necessarily solid, but I would say that, we're looking to make things a lot more standard. The reason why Camera X is powerful is because we also have our own test suites as well, right? We have literally a lab. I think we just recently posted a blog post about it, like why you should use Camera X, because we actually test so many things for you. CTS testing, making sure that the rotation is happening well on several different device models and manufacturers to provide a more consistent experience when using the library, right? And in going towards that route, you get all of these things for free. Whereas if you go Camera 2, here's the perfect analogy. Camera X is kind of like a pre-built plane, like an airplane. It's like, here's how you fly this thing, okay? Camera 2 is like, here's all of the pieces of an airplane. You have to build the whole airplane yourself. And so it's kind of like, in that way, we're trying to just standardize how it goes in terms of, like, just making sure that everything is pretty much as good as we can get. I would love more feedback on that, actually, and how we can improve the quality overall.
You definitely are not selling the ease of use of Camera 2. So, all right. So, is there any plan to change the DEX file format to remove the 65K method limit? Any thoughts?
I haven't heard anything.
All right. There we are. We don't know.
I think we've learned to live with it.
We've learned to live with it. Yeah. So one of the questions is when we've obviously implemented dynamic color. And how does an app maintain its own integral brand while still leveraging this really important feature for users to be able to customize their device?
I think this is a very important question. Yes, so I touched upon it briefly. When you're creating up your theme, you can actually extend the out-of-the-box dynamic color tokens to create any additional color tokens you might need. So the example I gave before was, maybe you always want that hang-up button to be red. So you can actually go and create that custom token for that, hang-up red color that you might have. Now, there are kind of two ways that you can kind of then take this. So either you decide that the color can be harmonized. So out of the box from Android 12, there's a harmonized color API, which will actually harmonize that color. So you might upload a certain color, but then it might get shifted to ensure that it meets all of those amazing contrast ratios that I was touching upon. And if you don't want the color to be touched at all, potentially in the brand example, if your brand color is say yellow and you always want to have that yellow in a particular hue of that yellow, then you can actually just extend it and not harmonize it at all. Something I would then plug is then the Material Theme Builder. The Material Theme Builder has a Figma plugin and you can access it on the web where you can actually upload, an example wallpaper and actually test what the different colors would look like and try to work out exactly what you want. And then from there, you can actually export either the compose files of the themes and colors and type or XML ones if you're in a view-based app. And so there you can actually then just extract that straight into Android Studio, test it out how it looks, and so ultimately getting the experience that you want.
So for a long time, we've had notification channels in Android, and now we have the new notification permission. How does this work with notification channels?
I think we've always had these notification channels, but I think what we were seeing is that it's a lot for people to actually manage all of these individually, and more importantly, we weren't seeing a lot of people actually going into settings and changing things. What we wanted to do with the permission actually is bring this up front for people to make that choice, so that they know exactly whether or not they want to let an app grant this permission or not. And just like most things, we want to make sure that people exercise that choice. And so they work hand in hand. The notification permission is an overarching yes or no, and then the channel still exists. So if people want to go in and say, you know what, I want these kinds of notifications and not others, that choice still exists. It's not going away. But the change with the notification permission is just to ask that upfront. So instead of by default granting the app the permission, we are now asking users to make that choice upfront.
Yeah, and we've always had the big toggle for like notifications for the application where they're on and off. So it's really just surfacing that toggle up at it starts out off now, and you have to get it turned on.
Yeah, I think it's kind of nice because for an app they've already should be able to handle the case where they don't have notification permission. So this just makes it clear to the user. We're almost out of time, but last question is if you want to learn about Android, especially as a beginner, where's the best place to go? Any thoughts from the panel?
Your IDE, start writing code.
I think the developer relations team recently put out a Jetpack Compose Android Basics course. That's a really good place to start learning Android, including how to start building your app and the best practices to follow from the start.
I personally like to learn from example, and we have tons of samples available to kind of parse through and learn from based on what sorts of use cases you're looking at. So highly encourage you to dig into all of our sample apps.
Learn Kotlin.
And leverage the out-of-the-box templates in Android Studio. So you don't need to start from scratch. There's actually a lot of good templates that you can use, extend and copy and paste the examples diligently, and then from there you've got already basically an app up and running.
And I did want to mention we've got Compose camps going on around the world, so you can sign up and you can learn with others if that's how you learn better. And that's all we have time for today. So thank you so much for submitting your questions, and huge thanks to the panel for coming up here and asking them live. And we're going to continue the Android Dev Summit live stream with a bunch of interesting talks, so stay tuned. All right.
Hi. My name is Yasin Reski, and I'm part of the Developer Relations Engineering team on Android working on privacy. Today, I'll tell you everything you need to know about storage on Android, which APIs to use, and the best practices you should follow. Let's first have a look at how storage is architected on Android. A device has a primary storage volume stored on flash memory or on a hard drive where the OS and apps are located. When Android installs an app, it creates a directory for the app's internal storage on the same primary storage volume. It's private and accessible only to that app, so it's the right place to store anything confidential like databases, configuration files. Android also creates a directory for the app's external storage. It's another location to save app-specific files. Some devices may have limited space available on the primary volume, thus making the app external storage only available through a microSD card. As the external storage can be removable, you always have to check its availability before using it. Keep in mind that before Android 11, the app's external storage is readable and writable by other apps that have the right storage permissions, so don't store any sensitive information there. Both the app internal and external storage directories are deleted when the app is uninstalled. And finally, there's the shared storage, also known as the device external storage. It's a common location for all apps to contribute files that can be seen in file managers and photo gallery apps. Files added there aren't deleted after apps are uninstalled. The shared storage content is automatically indexed by MediStore, which is a content provider that keeps track of metadata for shared storage files. It's used by apps to efficiently fetch information on all media files. These different types of storage locations can change on different Android versions. So if you're using file paths, don't save absolute path references to files, but instead keep relative references from the root of these different storage locations. Now we'll look into scope storage. Up to Android 9, files in the shared storage were readable and writable by apps that requested the right permissions. On Android 10, we released a major privacy upgrade regarding shared files access named Scope Storage. When an app requests read external storage on this version, access to shared storage is restricted to media files like photos, videos, and audio files. Any other files like PDF, zip, or docx, known as document files, are accessible using the document picker, which leverages the storage access framework. The document picker allows the user to retain full control on which document files they give access to. We also introduced other changes to further improve privacy and the developer experience. Write external storage is deprecated, and adding files to the shared storage does not require any permission. Requesting explicit user consent with a dialog shown to them when modifying or deleting a media file is now required. And finally, location metadata is removed from media files automatically, and to access them, you need to request access media location permission. Now we'll deep dive into common storage use cases. Let's say our app downloads some user data in a config file that you want to keep private. First, we'll use OKCTP. It's a popular open source library to create and execute our HTTPS request. We'll create our client, and now we'll get to the response. Once we get the response back, we double check that it has a response body. We rely on the .use method from the Kotlin standard library to close the underlying network socket automatically at the end of the lambdas to avoid any memory leaks. Finally, we save the request body into a file. As the file content is private, we'll save it into our app's internal storage using the context.filesdir property. To streamline our memory usage, we'll copy the request body content into our file by using streams instead of holding it entirely in memory. The Kotlin standard library has the .copy_to extension function to input stream instances to facilitate the copy towards output streams. Now, let's imagine that we need to download some large assets in our app that aren't confidential but are meaningful only to our app. So we would like to avoid polluting the shared storage with it. We would follow the same instruction as we did in our previous example, saving the big file to the internal storage as is the most available and performant storage location. Some devices may have limited space available on the primary volume, so we should check first if there is still some enough space there. If there is not enough space, we use the app's external storage directory. We should rely on the .get external filesdir method, as the device may have extra volumes like a microSD card. Finally, if there's still not usable space, let's show a notice to the user explaining the situation. Now, our app needs to add files to the shared storage, so the user can access them through other apps. If we want to add an image, we need to request the right external storage permission up to Android 9. On more recent devices, we don't need this permission anymore to contribute files into the shared storage, thanks to scope storage changes introduced in Android 10. For images, we will choose the Pictures folder returned by the environment.getExternalStoragePublic directory method using the environment directory pictures constant. If we're adding a video, we will choose the movies constant folder. If it's a PDF file, we will choose the download folder, etc. Now that we've copied the image into a new file, we need to scan the file using Media Scanner by providing its path and its MIME type. It will index the file metadata inside MediaStore, making it visible when apps query this content provider. For the best performance and access to more features like favorite, trashed, and pending files on Android 10 and above, we recommend using the MediaStore API to add files on the shared storage instead of relying on the File API. Check out our documentation for more details. Now let's go to another use case. Let's say we need to access document files, so we will rely on the document picker via the action open document intent. First, let's add the Jetpack activity dependency to our project if it's not there already. After that, we register our open document activity result, which will handle the intent result logic. If the user has selected a file, we'll have a URI that we can open using the content resolver. Finally, we launch our intent handler with the MIME types we want to filter on, and in this case, it's a PDF. The action open document intent is available on devices running Android 4.4 and higher. To access photos and videos on the shared storage on version up to Android 12L, you had to request read external storage and implement your own UI for the user to select the different items. But wouldn't it be better to just use something simpler for developers and privacy-friendly for users? Say no more. In Android 13, we introduced the photo picker, a privacy-forward way to select for images and video. It doesn't require any runtime permission and has a better UX to access photos and videos. It's maintenance-free, and you can even limit the number of selectable items. You can integrate it in your code in just a few lines of code, and it's backported to Android 11 and 12. In the upcoming months, cloud media providers like Google Photos will also be supported. The photo picker will seamlessly include backed up photos and videos to the selection grid, even if they are not saved on your device. Users will even see their custom and shared albums in the Albums tab. To use it, let's add the Jetpack activity dependency version 1.6 and higher to our project if it's not there already. After that, we register our Pick Visual Media activity result, which will handle the intent result logic. It will use the photo picker when available on the device and fall back to document picker for older devices. If the user has selected a file, we'll have a URI that we can open using the content resolver. Finally, we launch our intent handler with a filter: image and video, image only, video only, or specific MIME type we want to filter on. And that's it. 3 lines of code to select an image or video without permissions. If you want to keep access to a file even after your app is closed, you can call the take persistable URI permission to be able to keep access to them even after reboot. Your app may have a use case requiring this broad access like gallery photo backup. For these specific usages, we've introduced new permissions in Android 13 when targeting API 33 that provide access to specific types of media files, including images, video, or audio. You can read more about them in the documentations. Privacy and transparency have been tremendously improved over the recent releases of Android, with even UX enhancements like the photo picker. We're working on adding more APIs that keep the user in control of giving access while removing the need to request permissions on app sites. And lastly, as a recommendation for apps, rather than relying on file paths, which only offer access to local files and can be changed over different versions of Android, we're recommending to use URI to access files on Android. Have a look at our documentation for more details on the features I've presented today. Thank you.
Hi, welcome to Android Dev Summit. I'm Phong Nam, Developer Relations Engineer from Android. And today, I'm going to tell you how to keep your app from failing in a 64-bit only world. Android hardware is always changing. Sometimes the hardware change is highly visible, like from a regular screen to widescreen to ultra widescreen. And sometimes it is not. If you are building an app for Android, I think you must be familiar with the device available in the market. Generally, there are two types. Some Android devices are 32-bit only. They are usually mobile devices for the low-end market, or TV and wearable devices. And the majority of mobile devices are 32-bit plus 64-bit mixed mode devices. Now, it is a bit different after the Pixel 7 is launched. Pixel 7 is the first Android phone configured as 64-bit only. And as forthcoming high-end SoC cannot run 32-bit code, this will be a big thing next year. Every developer should get ready for this. We expect 64-bit only to be the default options in the future. You may ask, why drop support for 32-bit code? Well, of course, there are a few advantages for doing this. First, it is faster. 64-bit applications run faster because they have access to extra registers and instructions that are not available to 32-bit apps. Secondly, it is safer. The bigger address space make defense like ASLR more effective, and the spare bits can be used to protect control flow integrity. And the new hardware instructions get added to 64-bit, but not 32-bit instruction sets. Thirdly, it improves system health. Removing support for 32-bit code saves up to 150 megabytes of RAM, which has been used by the OS even when it is not running 32-bit applications. And finally, starting in 2023, next year, high-end SoCs will no longer be able to run 32-bit code. I think you also remember that from August 1st, 2019, app published on Google Play will need to support 64-bit architecture, right? So does it mean that you do not have to do anything and your app will be running without issue on these 64-bit only devices? Maybe. Have you ever tested your app on a 64-bit only environment? No, right? Because 64-bit only devices were not in the market before. Different Android devices use different CPUs, which in turn support different instruction sets. Each combination of CPU and instruction sets has its own application binary interface, ABI. How do I know if the device is a 64-bit only device or not? You may check the value of build.support ABIs. It will tell you the supported ABIs of the device. And supported 32-bit ABIs will be an empty list on 64-bit only devices. Okay, my phone is not a 64-bit only device. What should I do? You can use the emulator. Starting from Android 12, the emulator is 64-bit only. And of course, we know that, Sometimes it's just too difficult to test your app on an emulator. So very soon, you'll be able to download a 64-bit only image for some older Pixel devices. Flashing it will make your Pixel a 64-bit only device so you could do the testing. If you install your app with ADB, you could supply --ABI as a parameter to indicate which libraries to install to the device. This also makes sure you are installing the 64-bit part of your app to the device, not the 32-bit one. By specifying the ABI to install, you will be able to install only the 64-bit part of your app to the device. If your APK doesn't support 64-bit ABI, an error message will be shown. So, what should you do after the install? Of course, testing. Testing is so important, and some SDKs or libraries may have wrong assumptions and may cause crashes at one time. For example, the SDK may be still looking for the path -lib, not -lib64. The path -lib still exists in a mixed mode device, but it may or may not exist in a 64-bit only devices. So your app may run on most devices, but fail on some 64-bit only devices. Another example is about the new instruction set in the new architecture. These instructions, such as PAT and BTI in ARM v9, enhance security. But some SDK crash because of this. We'll go through some specific example next. We have identified a few SDKs that are not compatible with 64-bit only devices. Most of these SDKs have released a new version which fixes the problem. If you are using any of these SDKs, update it to the latest version. If you find an SDK having issue with 64-bit only devices, report to us. Some old versions of SLoader have a bug in identifying the library path when running in a 64-bit only environment. This also affects SDK using SLoader, such as React Native, Facebook Yoga, and Fresco. The recent release of SLoader also fixed some other compatibility issues. So if you are using SLoader, make sure you are using the latest version. Similarly, some old versions of OpenSSL have a bug in handwritten assembler that causes PAC failure. Again, check which version you are using and make sure you are using the new version with the fix. If your app is using some app shielding solution, please make sure the solution is working when PAC and BTI are enabled. Contact your vendor if you see issue. If you are publishing your app on Play, here is some good news for you. Google Play can tell you is your app affected by old version of some popular library such as SLoader. And make sure you have opt-in to the pre-launch report. Why? Because pre-launch report now support testing with a 64-bit only hardware, which means you could identify many 64-bit related issues from the pre-launch report. You could see the errors if your submitted package is having issue. Please make sure you visit Google Play Console so you don't miss the message. Thank you, and remember to check out developer.android.com for more information. We are adding more content about 64-bit there. See you again soon.
Hello, I'm Garen, and I'm part of the Android Developer Relations team. At I/O this year, we announced Health Connect, the platform for sharing health and fitness data between apps on the Android ecosystem, that is both secure and gives the user full control of their data privacy. Today, we're going to look a little deeper at the practicalities of keeping your app in sync with Health Connect data. If you're new to Health Connect, that's okay. Head on over to developer.android.com/healthconnect and learn about how your app can benefit from a Health Connect integration. And then come back and join us. Let's quickly recap on the role of Health Connect. Imagine you are developing a workout app, as shown here. The user may use additional apps, such as a sleep tracking app and a nutrition app. Each of these apps could benefit from insights from the other. Yet there is no easy way to share health and fitness data between them. Enter Health Connect. Your workout app could consume data from Health Connect, which has been supplied by the sleep app. Perhaps if the user has had a poor night's sleep, your workout app could make different recommendations for exercise that day. Equally, by feeding data to Health Connect from your app with the user's consent, the user can realize benefits in other apps they may use. For example, the user may also be using a nutrition app. This app could make different recommendations depending on the levels of activity. But how can you keep track of what to read and write and when? Let's take a look first at feeding data into Health Connect from your app. Health Connect provides a convenient API to ensure both new and updated data can be written to it. We'll take an example of feeding steps data into Health Connect from your fictional workout app. Your workout app has its own database, and steps data is represented using the My Steps model class shown. We're going to use the insert records method to perform the writing. This simply takes a list of records and writes them to Health Connect. However, The important step when used for synchronization is to use the metadata property. First, specify the client record ID and use the unique key from your app's own database. This determines whether to insert this record as a new record or whether to update an existing record in Health Connect, ensuring no duplication of data. Also, specify the client record version and use a version identifier from your app's own database, such as the last modified time. When updating data, Health Connect uses this to determine which record to keep. Once you've defined your record objects, call Insert Records, passing in your list of records. Health Connect will determine whether to insert or update records accordingly. And note, there's no need to use Update Records method at all. So that's how to feed data to Health Connect. Here's some practical considerations to ensure your integration works smoothly. For simple measurements, like a weight measurement or a blood pressure measurement, write the value immediately. For larger sets of data, for example, all the data from a long workout, batch the data up, for example, 1,000 records at a time, and write at a convenient point, for example, at the end of the workout. Also, use Work Manager to implement a robust means for writing the data. Finally, be sure to handle errors. If there is an error, adopt a retry policy, but ensure that your app can move past this point if the failure continues. Now we've seen how to contribute data to Health Connect, let's look at how your app can consume Health Connect data. Health Connect provides API methods for simply reading data, such as read records and aggregate methods shown here. However, to keep your app's data store up to date with Health Connect on an ongoing basis, use the Changes Sync API. Let's look at this concept. When you want to retrieve the changes to step count data, you supply a changes token and receive a list of changes that have happened since that token was made, in addition to a new changes token to use next time. So how do you get hold of your first token? I'm glad you asked. Use getChangesToken to obtain a token, for example, for steps, as shown here. Let's take a look now at some code for using the changes token to get the list of available changes. You can see here the call to get changes, supplying the token we obtained just previously. Also notice how it is important to distinguish between inserts, updates, and deletions. Finally, store the latest ChangeSync token in your app, and you're then good to go for getting the next set of changes when you need them. Before we move on to some practical considerations, let's look at the changes themselves in a bit more depth. Each change will contain an ID in the metadata. You should store this ID in the record in your app's own database, as this will allow you to differentiate future updates from inserts. Just like with feeding data, here are some best practices for ensuring a smooth experience consuming data from Health Connect. The Changes Sync API will return all changes, including ones that your app wrote itself, so be sure to filter these out using your package name. Remember that your app can only read data from Health Connect when it is in the foreground, so be sure that your implementation can handle being interrupted and is able to pick up where it left off. The Changes Sync token has a lifetime of 30 days. You'll need to handle the case where the token has expired. Finally, if the user can independently toggle on and off different data types, be sure to use separate Changes Sync tokens for each. Now you know how to keep your app in sync with Health Connect, allowing your users to benefit from greater health and fitness insights across their choice of apps. For more information, visit the Health Connect page at developer.google.com/healthconnect.
Hi, I'm Carlos Vinuesa from the Android Developer Relations team, and I'm here to talk to you about ultra-wideband. In this session, we will see an introduction to ultra-wideband technology and real-life examples on how it can be used, then an overview of our new Jetpack library for building apps with UWB, and finally, a walkthrough of some code to see how to use it. So, what is ultra-wideband? Have you ever walked to your front door with your hands full of grocery bags and wished that the door could unlock on its own? Or what if that podcast that you're listening in the kitchen transferred magically to the garage's smart speaker just as you get there? Well, this technology could enable all that and more. Think of it as a precise high-frequency radar built into your Android phone. Ultra-wideband, or UWB, is a technology that enables secure and accurate communication at very short ranges. It can measure distance, angle, and elevation as close as 3 inches or 10 centimeters, and unlike GPS, also works indoors. So, what kind of experiences can you build with UWB? I mentioned some already, but here are a few more. You could use it as a highly secure data transfer mechanism to exchange credentials between two Android phones in close proximity, or as a digital car key to unlock your car and start it automatically as you approach it, or to enable new home control possibilities, like for those times when you cannot find the TV remote, you could replace it momentarily with your phone to select some media on the screen, while at the same time ask your phone to find the remote for you, that happened to be under the couch again, because thankfully it had a UWB beacon in it. So, now that we know a bit more about UWB, let's take a look at our new Jetpack library to see what it can do. We launched the alpha version of the library earlier this year. It currently works on devices with Android 12 or newer, enables phone-to-phone or phone-to-IoT device use cases, and like all our Jetpack libraries, plays well with Kotlin. It comes ready with UWB controller and controllee ranging profiles. If you're wondering what those are, don't worry, we'll talk about them later. And it's compatible with FIRA MAC 1.3 compliant accessories. FIRA is the group that coordinates companies working with UWB, and Google is an active member. And MAC 1.3 is the spec that defines things like how the communication works, messaging format, encryption, etc. The library has a few restrictions. Only foreground apps and services are allowed to start a new session. So if the app goes to the background, the client will no longer receive reports. But those will resume once the app or service moves back to the foreground. These constraints are there to preserve optimal battery usage, but may change in the future as we continue to improve the library. Now, before we look at the code, let's review a few things you need to know. Your out-of-band mechanism, the role of your app in the communication, and the configuration needed for the devices you will work with. The out-of-band, or OOB, is just the way UWB devices find each other. UWB doesn't have a native discovery mechanism, and the Jetpack library does not provide one either. So you will need to choose one for your app and implement it before you start a UWB session. BLE scan and advertisement is the most common used OOB, but you could also use other RF technologies like Wi-Fi, GAT, or the Nearby Connections API. We will review an example later in the video. A UWB ranging session happens between a controller and one or more controllees. Ranging here is just the calculation of time taken by the radio signal to travel between devices and the distance between them. A controller defines the communication channel, starts the session, and sets the parameters to be used. And the controllee device that responds to the controller calls. If you plan to develop an app between two Android devices, you have to decide which one will play each role. On the other hand, if you're ranging from an Android phone to another IoT accessory, typically that device will be the controller. And the last thing you have to decide is the right configuration for your devices. The library provides configuration sets with predefined parameters like type of ranging session, ranging interval, security type, etc. In the current alpha version, however, there's only one available, config ID 1, that when selected sets the channel and security type to static STS. We're working closely with our UWB partners to add more configuration sets in the future. Now, with all those concepts out of the way, let's take a deep dive and finally look at some code. First of all, you need to add the library dependency in your project configuration. In this example, we're setting it to the latest version, Alpha 3. Then, as a good practice, always check if the Android device supports ultra-wideband. Pixel 6 and 7 Pro and some of the latest Samsung and Xiaomi devices already do. You can query for this feature using the hardware UWB string in Package Manager. The next step is to discover and create the OOB connection between the devices. With BLE, in this example, it is as simple as getting a reference to the BLE scanner, configure it with the appropriate service UUID, and do a regular Bluetooth scan. If your app is going to be both controller and controllee, this service UUID is usually defined by the app. If the app is only controllee for another controller, that ID will be provided by the device manufacturer. When you use BLE as a OOB mechanism, all the information about the UWB device can be extracted directly from the service data byte stream, returned by each scan record object. The key pieces of information to search for are the UUID, the UWB address, and UWB channel. Once discovery is complete and you capture the required information from each device, you need to initialize your session by getting an instance of UWB Manager and then call controller session scope on the controller or controllee session scope on the controllee. Keep in mind that Android allocates a new random address for every new session. So this needs to happen before you exchange parameters with your UWB peers. After the sessions are initialized, you have to exchange your device parameters. Controller and controllee exchange their local addresses, which on Android can be obtained from their corresponding session scope objects. And for accessories, it should be provided by the vendor. The controller also needs to share the UWB channel that on Android is automatically generated and can be retrieved from the UWB controller session scope object, and optionally, a session key to be used for the ranging. If the profile uses static STS security, this is a byte array with vendor ID and security type information. Now, you need to set those parameters in the corresponding ranging parameters object, like you see here. And then call prepare session on the object. This will return a flow of ranging result objects. A flow is just an asynchronous data stream that, when consumed, initiates the UWB ranging session, and then returns a collection of ranging result position objects. And that ranging result position object is the one that contains the detailed information about the UWB device, the distance in meters between controller and controllee, and the azimuth and elevation angles relative to the other device. Oof, that was a lot of information, but if you just want to take a few things with you today, just remember this. UWB is a very accurate and secure technology that lets you know the exact position of other capable devices at very close range, 3 inches, indoors and outdoors. Our new Jetpack library empowers you to build apps for Android 12 or newer devices that support UWB, and you can make your app behave like a controller or controllee. So, check the documentation and samples provided in our developer site and let us know what you think. We cannot wait to see what you can build with UWB. Thanks.